Hello, welcome to Easy Maths for Everyone. With Easy Maths for Everyone, concept simplified and success amplified. Solving previous year papers is important because it helps you understand the exam pattern, identify the high priority topics and improve your time management, thereby helping in developing strategies within the limited time. Also, it helps to enhance your problem solving skills and in boosting your confidence level by reducing the exam anxiety. Also, solving papers reinforces understanding of core concepts and highlights the areas where you need more attention and revision. My humble request to you is, rather than watching this video, do solve the paper along with me. Do pause the video after every question is displayed, and once you are done, check your answer with mine. Hope you are ready with your pen and papers. Without further ado, let's get started. The paper we are going to discuss today is the board paper for 2024-25 batch, and the paper code is 65/1/1. To begin with, let's solve the sums from section A, which are MCQs carrying 1 mark each. First question, if A equal to the matrix -1 0 0 0 1 0 0 0 1, then A inverse is, we know that A inverse equals 1 by determinant of A into adjoint matrix of A, but we can't do this method because this is a time consuming process. We can't spend that much time for one MCQ. So we are going to use another way. We know that A times A inverse equal to I, right? So we can try multiplying A with all of these matrices, trial and error only. All of these matrices taken one at a time, and then we will check if the product is giving you I as the answer. So when we check that way, we can see that the option D, when multiplied by matrix A, gives us I as the answer. I will show you. So A equals -1 0 0 0 1 0 0 0 1, and the other matrix we are going to take is option D matrix, which is -1 0 0 0 1 0 0 0 1. So when we multiply both of these, let's see what happens. -1 0 0 0 1 0 0 0 1 multiplied by -1 0 0 0 1 0 0 0 1 equals, row 1 into column 1 is -1 into -1, which is +1, plus second entry of row 1 and second entry of column 1 0, and third entry into third entry is 0. And the first row second column answer is -1 into 0 0, 0 into 1 0, 0 into 0 0. And the first row third column answer is -1 into 0 0, 0 into 0 0, 0 into 1 0. Same way, second row first column answer is 0 plus 0 plus 0, and second row second column answer is 0 plus 1 plus 0, and second row third column answer is 0 plus 0 plus 0, and third row first column answer is 0 plus 0 plus 0, and third row second column answer is 0 plus 0 plus 0, third row third column answer is 0 plus 0 plus 1. So this gives you 1 0 0 0 1 0 0 0 1, which is the identity matrix, correct? So when we multiply the option given in D with A, we are getting I. So A inverse will be the matrix -1 0 0 0 1 0 0 0 1. So option D is the correct answer. Let's do the next sum. If vector A is equal to 3i plus 2j minus k and vector B equals I minus j plus k, then which of the following is correct? There are 4 options. See, we can do trial and error here also. When will we say A vector parallel to B vector? Let's think about it. When vector A equal to lambda times vector B, or vector B equals some mu times vector A, that is when we say both A and B are parallel to each other. Correct? But here there is no way that when we multiply vector B with some number to get our A vector, or we can multiply vector A with some number to get B. Both are impossible. So A parallel to B is not correct. Yeah. And let us go to, I'll do option B later. And option C and option D both are involving lengths of the vectors. So let's quickly do the lengths. So length of A will be square root of 3 square plus 2 square plus negative 1 square, which is square root of 9 plus 4 plus 1, which is root over 14. And length of B vector will be root of 1 square plus minus 1 square plus 1 square, which is root of 1 plus 1 plus 1, which is root over 3. So length of B is smaller than length of A. But here in option C, they are saying the other way. Length of B is bigger than length of A. So this is also wrong. And length of A and length of B are not same, because you can see length of A is bigger. So this is also not correct. So eventually we have only one option, but we can prove that also. When will we say A vector and B vector are perpendicular? When their dot product is equal to 0. Right? So let us take dot product between A and B. So A vector is 3i plus 2j minus 1k, and B vector is 1i minus 1j plus 1k. So A dot B will be 3i plus 2j minus k dot I minus j plus k. So this will give you coefficients of I in both the vectors product and coefficients of j in both the vectors product 2 times negative 1 plus coefficients of k in both the vectors product is minus 1 into plus 1. So this is 3 minus 2 minus 1, which is 3 minus 3, giving you 0. So when A dot B equals 0, that means A vector perpendicular to B vector. So option B is the correct answer. Let's go to the next sum. Integration of modulus x by x dx between the limits minus 1 to plus 1 when x is not equal to 0 is equal to which of the options? So we have to understand something. We know by the definition of modulus x that modulus x takes different values when x is positive and negative. So modulus x is minus x if x is less than 0. Modulus x is x itself if x is greater than or equal to 0. Since we have minus 1 to plus 1, this is a different zone and this is a different zone. So when x belong to minus 1 comma 0, 0 is not included. This time modulus of x will be equal to minus x, correct? And when x belong to the interval 0 comma 1, modulus of x will be equal to plus x. So because of the different values of x here, we cannot do this integral together as a whole. So we need to split this integral, and this is obviously possible. We can do that because when we have a to b f of x dx, the property says if there is a c which lies between a and b, we can split it like integral a to c f of x dx plus integral c to b f of x dx. So doing the same here, integration between minus 1 to plus 1 modulus of x by x dx equals minus 1 to 0 modulus x by x dx plus integral 0 to 1 modulus x by x dx. So carrying on further, this equals integration between minus 1 to 0. Modulus of x in the range minus 1 to 0 is minus x. So minus x by x dx plus integral 0 to 1, and value of modulus x in this range is x. So x by x dx. So this is equal to integral minus 1 to 0, minus x cancels in both the integrals. So we get minus 1 dx plus integral 0 to 1 plus 1 dx. So this will give you minus x as the answer, isn't it? Minus 1 to 0 plus integral x between 0 to 1. So when we put the values, you can take the minus outside in the first bracket, minus x between minus 1 to 0 plus this is just upper limit value minus lower limit value, and this one will be minus of upper limit value minus lower limit value, and this is just a 1. So the first value will give us minus 1. So minus 1 plus 1 is going to give us 0 as the answer. So option B is the correct answer. Let's move on to the next sum. Which of the following is not a homogeneous function of x and y? First of all, we should know what is the definition of a homogeneous function. So a function is homogeneous function if f of tx comma ty equal to t power n times f of x comma y. So whichever function given here obeys this rule, we can accept that is a homogeneous function, and which is not obeying, we will say that is the required answer. First one, let us consider given in option A. So if we take it like f of x comma y, which is y square minus xy, what can be our f of tx comma ty? That will be replace y with ty and x with tx wherever x and y are available. So this will become ty to the power 2 minus tx times ty. So this becomes t square y square minus t square xy. So we can take t square outside and this becomes y square minus xy. And the item in the bracket y square minus xy is nothing but our f of xy. So this becomes t square times f of xy. So this is a homogeneous function which is given in option A. Same way we can check for every other value. Let us take the function given in option B, f of x comma y equal to x minus 3y. So f of tx comma ty will be tx minus 3 times ty. If you take t outside, you get x minus 3y, which is again t times f of x comma y. So this is also a homogeneous function. And what do you mean by this n in the power of t? That is the degree of the given function. Hope you can see the first function given in option A is of degree 2. That's why we are getting t power 2 f of xy. Same way, the function given in option B is linear function, right? So degree is 1. So we are getting t power 1 times f of xy. So option B function is also homogeneous function only. And let us take the function given in option C, and f of x comma y equal to sine square y by x plus y by x. This is the given function. Let us calculate f of tx comma ty. This will be sine square of replacing y and x with tx and ty. We get ty divided by tx plus ty divided by tx. Hope you can see that t cancels in the bracket of both the items. So we are getting just sine square of y by x plus y by x as the answer. There is no t, that means t power 0 times, like this. So this is also a homogeneous function only. So now let us consider the function given in option D. Let us take it like f of x comma y equal to tan x minus secant y. So when we find out f of tx comma ty, it will be tan of tx minus secant of ty. And there is no way we can write it like t power n times f of x comma y, right? So the function given in option D is not a homogeneous function. So correct option is option D. Let us go to sum number 5. If f of x equal to modulus of x plus modulus of x minus 1, then which of the following is correct? Option A, f of x is both continuous and differentiable at x equal to 0 and x equal to 1. And option B, f of x is differentiable but not continuous at x equal to 0 and x equal to 1. Option C, f of x is continuous but not differentiable at x equal to 0 and x equal to 1. Option D, f of x is neither continuous nor differentiable at x equal to 0 and x equal to 1. So before doing this, let us try to the graph of modulus x function. It will be something like this. And let us recollect about the modulus x minus 1 function, which will be like this is 1 here. So it will come and touch 1 and then return back like this. So modulus x touches the x-axis at 0 and modulus x minus 1 function touches x-axis at 1. Okay, hope you guys know that modulus x and modulus x minus 1 both are continuous. There is no doubt about that. But about the differentiability, modulus x and modulus x minus 1 both are not differentiable. Especially when the curve takes a sharp turn. Wherever the curve takes a sharp turn, one V-shaped turn is happening, the curve usually won't be differentiable at that particular point. So where the turn is happening at 0 and 1, so both the curves are not differentiable at that particular points. Correct? So we already know one more thing. Whenever we have f of x equal to f1 of x plus f2 of x, if f1 of x is continuous and f2 of x continuous, then their is also continuous. So since we know that modulus x and modulus x minus 1 both are continuous separately, their sum is also continuous, no doubt about that. So f of x is continuous. And about the differentiability, first function f1 of x is not differentiable at x equal to 0, and the second function f2 of x is not differentiable at x equal to 1. So what we can conclude here is f of x is continuous but not differentiable. So option C is the correct answer. Now let us go to the next sum. Sum number 6. If A is a square matrix of order 2 such that determinant of A is equal to 4, then determinant of 4 times adjoint of A is equal to which of these options? First of all, we need to remember some formula over here, which is determinant of k times A equal to k to the power n times determinant of A, where this n is the order of the matrix A. So here given A is a square matrix of order 2, so n is equal to 2 here. So determinant of 4 times a matrix, whatever matrix it is. Suppose if it is a matrix B, we are going to take adjoint matrix of A as our matrix B. So this is what we want to find out. So determinant of 4 times matrix B equal to 4 to the power n times determinant of B by the formula we know. Since here the order is 2, we can say this is 4 power 2 times determinant of B. Recalling another formula, determinant of adjoint of matrix A equal to determinant of A to the power n minus 1. So we are using two formulae over here. So we are calling adjoint of A as B, right? So determinant of B equals determinant of A is given as 4 here. So 4 power n minus 1 means 2 minus 1, which is 4 power 1, 4. So we can use this value in here. So finally determinant of 4 times B equals 4 square into 4, which is 4 power 3, 64. Therefore, determinant of 4 times adjoint of A equals 64. So, the correct answer is option B. Let's go to the next sum. Sum number 7. If E and F are two independent events such that P of E equals 2 by 3 and P of F equals 3 by 7, then P of E given F bar is equal to, we can use two ways here. The straight cut formula is E given F bar equal to P of E intersection F bar divided by P of F bar. And we know that E and F are independent events. So, E and F bar also independent events. So, we can write P of E intersection F bar like P of E into P of F bar, and that's the condition for independent events. So, this we can find like 2 by 3 into P of F bar is 1 minus P of F. So, this will become 2 by 3 times 1 minus 3 by 7. So, this becomes 2 by 3 into 4 by 7. And the final answer for this is 8 by 21. So, P of E given F bar will be 8 by 21 is the numerator's answer, and P of F bar is this one in the bracket. So, that will be 4 by 7. This will be 8 by 21 times 7 by 4. This will give you 2 by 3. One more thing we can directly apply here, a shortcut way we can apply here is whenever P of A given B, they are asking if A and B are independent events, then P of A given B is nothing but P of A. So, we can apply this and directly we can tell the answer without even doing all these calculations, that P of E given F bar is equal to, when E and F are independent events, then E and F bar are also independent events. So, P of E given F bar will be simply P of E, and P of E is 2 by 3. By calculation also we got the same answer. So, we don't need to waste this much time, right? So, correct answer is option C. Let's go to the next sum. The absolute maximum value of the function f of x equal to x cube minus 3x plus 2 in the interval 0, 2 is, so you know by the procedure of absolute maximum value, we need to find critical points. So, we need to find the critical points, also the value of the function at the endpoints. I mean f of 0 and f of 2, and whatever critical points we are getting, those values also we have to find out. For example, if we take the critical points like C1 and C2, then we need to find f of C1 and f of C2. So, we need to compare all of them, whichever is the maximum among all the four, that will be our absolute maximum value, correct? So, for that process, we need to maximize the function first. So, let us take f of x, x cube minus 3x plus 2. So, f dash of x will be 3x square minus 3 times 1 plus 0, which is 3x square minus 3. And let us keep the second derivative also ready. So, it will be like 3 into 2x minus 0, which is 6x. First derivative equal to 0 implies, that's the process of finding the critical points, right? So, 3 square minus 3 equal to 0. That implies 3 times x square minus 1 equal to 0. That implies 3 is not 0. So, x square minus 1 is equal to 0. That means x plus 1 into x minus 1. That's the factorization for x square minus 1. That's equal to 0. This will give you x equal to negative 1 and positive 1. So, we got two critical values here. We need to check which one is the maximum among these two. So, let's put this value obtained in the f2 dash of x value. So, f2 dash of x equal to 6x. So, when we take x equal to negative 1, then f2 dash of x will be 6 times negative 1, which is minus 6 less than 0. So what kind of value is x equal to minus 1? X equal to minus 1 is a maximum point. Correct? And we need not take that 1 here because f2 dash of 1 will give you a value greater than 0. So 1 will give the minimum value, but we need the maximum value only. So we can ignore that 1 here. Just minus 1 is the value we need here. So we need f of 0, f of 2 and f of c1. We can ignore f of c2 as I told you. So let us find out f of 0. So f of 0 will be 0 cube minus 3 times 0 plus 2. We can put the values in given f of x, correct? So this is equal to plus 2. And f of 2 will be 2 cube minus 3 times 2 plus 2, which is 8 minus 6 plus 2, which is 10 minus 6, which is 4. And f of minus 1 will be minus 1 to the power 3 minus 3 times minus 1 plus 2, which is minus 1 plus 3 plus 2, which is 5 minus 1, 4. So the maximum value happens in two different points, right? 2 also gives you maximum value, minus 1 also gives you maximum value. But what is the absolute maximum value they are asking, which is 4 here. So option C is the correct answer. Let us go to the next sum. Let A equal to 1 minus 2 minus 1, 0 4 minus 1, minus 3 2 1, and B equal to minus 2 minus 5 minus 7, and the matrix C equal to 9 8 7. Which of the following are defined? See, you guys very well know that when the order of one matrix is m by n and the other matrix has the order n by p, then only A cross B is defined. Correct? So the number of columns in the first matrix and the number of rows in the second matrix both should be matching. Then only that product of matrices is defined here. So order of A matrix is 3 by 3 and order of matrix B is 3 by 1, 3 rows and 1 column, and order of matrix C is 1 by 3, 1 row and 3 columns. So when we find out A cross B, A is 3 by 3 and B is 3 by 1. See, the number of columns and number of rows in the second matrix both are equal to each other. So A cross B is defined. No doubt about that. And let us see AC, A into C. A is 3 by 3 and C is 1 by 3. Here number of columns in A and the number of rows in C are both not matching. So A cross C is not defined. So let us think about BA. So B cross A will be, B is 3 cross 1 and A is 3 cross 3. Here also the number of columns in matrix B and number of rows in matrix A both are not matching. So BA is also not defined. So these are the three matrices they are discussing here, AB, AC, BA. So by seeing the options here, we can very well say that only AB is defined and rest of them are not defined. So the correct answer is option A. Let's go to the next sum. Sum number 10. If integral of 2 power 1 by x divided by x square dx equal to k times 2 power 1 by x plus c, then k is equal to. So first of all, we have to solve this integration. Integral of 2 power 1 by x by x square dx on our own, and then we have to compare our answer and their given answer. Then only we will come to know about the constant k. So let's do that. So in this integral, we can use the substitution method. So we are putting 1 by x equal to some t. Then you very well know that minus 1 by x square dx is equal to dt. But we want to know what is 1 by x square into dx. So giving the minus sign to the other side, we will have 1 by x square dx equal to minus dt. So now changing the given integral 2 power 1 by x square dx, with our substituted values, we get integral 2 power t into dx by x square is nothing but minus dt. So this we can write like minus integral 2 power t dt. And we have this formula, integral a power x dx equal to a power x divided by log a plus c. So applying this formula here, we can say that this is minus 2 power t divided by log 2 plus c. So this we can write like minus 1 by log 2 into 2 power t plus c. Now compare their given answer k times 2 power 1 by x plus c and our answer. The place of k is originally taken by minus 1 by log 2. So option A is having that option. So k is minus 1 by log 2. That is the correct answer. Moving on to the next sum. Sum number 11. If a plus b plus c equal to 0 and length of a equal to root over 37 and length of b equal to 3 and length of c equal to 4, then the angle between b and c is. So first of all, what we are going to do is a plus b plus c equal to 0. That is given to us. So from here, we are going to find out b plus c's answer, which is 0 minus a, which is minus vector a. Now we need to find the angle between vector b and vector c. The formula to find out the angle between vector b and c is finding the dot product of them. That will be length of b into length of c into cos of the angle between them. But b dot c we cannot find here because we don't know what is vector b and what is vector c. So this formula, direct formula, is useless here. So we are going to do in another way. We know that for any vector p, p dot p equal to length of p square. So we are going to use this formula here to find out the angle between b and c. Let's just find length of b plus c whole square, which is b plus c dot b plus c. Distributive property, we get b dot b plus b dot c plus c dot b plus c dot c. And this will be, first one will be length of b square plus this is b dot c, and the next one also can be written like b dot c because you know that dot product is commutative, and c dot c will be length of c square. And we know what is length of b, which is 3. So 3 square we can write. These two we can add together, which is 2 times b dot c, and length of c will be 4, so 4 square. This side we have length of b plus c whole square. Of course, we can use the value of b plus c which we obtained from equation 1 here. So this is length of minus a vector square equal to 3 square plus 2 times b dot c plus 4 square. And continuing, we have length of minus a and length of plus a both are equal because length doesn't have any sign. So length of a square equal to 9 plus 2 times b dot c plus 16. So length of a is root 37, right? So root 37 square equal to 9 plus 16 is 25 plus 2 times b dot c. So we get root over 37 square is 37. So 37 minus 25 equal to 2 times b dot c. So 37 minus 25 is 12, correct? So 12 equal to 2 times b dot c. So this gives you 12 by 2 equal to B dot C. So B dot C equal to 6. B dot C equal to 6. Now you can apply the property length of B into length of C into cos of the angle between B and C equal to 6. So this is nothing but 3 into 4 into cos theta equal to 6. So we will get cos theta equal to 6 by 3 4s are 12. So 6 by 12 is nothing but 1 by 2. So theta will be is 60 degree or pi by 3 in radian measure. So option C is the correct answer. Let's move on to the next sum. The integrating factor of differential equation x plus 2y cube times dy by dx equal to 2y is. So we need to know what type of linear differential equation this is, because we have two types of linear differential equations. So the first type is dy by dx plus py equal to q, where p and q are functions of x or constants. This is one type of equation. And the second type of equation is dx by dy plus p dash x equal to q dash, where p dash and q dash are functions of y or constants. So depending on the type which it belongs to, the integrating factor will vary. So for the first type, the integrating factor is e power integral p dx. And for the second type, the integrating factor will be e power integral p dy. So we have to decide which type it is belonging to. So let us consider the given differential equation x plus 2y cube times dy by dx equal to 2y. So if we keep dy by dx in one side, we have to take this entire bracket to the other side denominator. We will get 2y divided by x plus 2y cube. Now we won't be able to split this into different values, two different values. So having dy by dx plus py equal to q becomes impossible. So we have to consider the second type. For that, we have to simplify the given equation in a different way. So let us flip this equation which we have here. So we can write the LHS like dx by dy and write the RHS like x plus 2y cube divided by 2y. Now this can be split into two fractions like x by 2y plus 2y cube divided by 2y. And this can be written like x by 2y plus 2 and one of the y's will cancel, we have y square. So finally we have dx by dy equal to x by 2y plus y square. This has to go to the left side. So we can write this like dx by dy minus 1 by 2y x equal to y square. So this is of the type dx by dy plus p dash x equal to q dash. So in this particular sum, p dash equal to minus 1 by 2y. Leaving x, everything else is our p dash, right? So p dash is minus 1 by 2y. So integrating factor will be e power integral p dash dy. It will be like e power integral minus 1 by 2y dy. So this will be like e power minus 1 by 2 can be taken out, 1 by y dy. And this will be like e power minus 1 by 2 log modulus y or ln modulus y. And this minus 1 by 2 has to go to the power, then only we will be able to cancel this. So that we will do here. This is equal to e power ln modulus y to the power minus 1 by 2, right? So this e and ln will cancel each other. We get modulus of y power minus 1 by 2, and this can be written like 1 by modulus of y power 1 by 2. See, when ln is there, modulus of y is required. When ln got cancelled, modulus of y is not even required, because y can take any value. When ln is there, that is when we have the problem. So this is y, just y. So this will be 1 by root y. So the correct answer is our option B. So let's move on to the next sum. If A equal to matrix A equal to 70x 070 is a scalar matrix, then y power x is equal to. So we should remember the definition of a scalar matrix. A square matrix whose diagonal entries or diagonal elements are equal and all non-diagonal elements are 0 or all 0 is a scalar matrix. So since it is given like A is a scalar matrix, it should be something like this: A 0 0 0 A 0 0 0 A. So comparing with the given value, we have 70x 070 00 y. So from this we can say that y is also equal to 7. And the first row third entry is 0 by the definition matrix, but we have a x here in the given matrix. So 0 and x should be equal to each other. So x should take the value 0. Once we decide the values of y and x, we need to find out y to the power x. So y is 7 and x is 0. So 7 to the power 0 is 1, because anything to the power 0 is 1 only. So the correct answer is option B. Now let us move on to the next sum. The corner points of the feasible region in graphical representation of an LPP are 2, 72, 15, 20 and 40, 15. If z equal to 18x plus 9y be the objective function, then which of the options we can choose here? So now we have to create the table for the points given. So let us take points in the first column and the objective function's value 18x plus 9y in the second column, and the final value of them we will take in the third column. So let's list them down here. The first point is 2, 72. The second point is 15, 20. And the third one is 40, 15. So we have to find the respective z values for all the points. So z equal to, replacing x and y with the given points 2 and 72, we have 18 into 2 plus 9 into 72. So when we simplify this, we will get a 684 as the answer. For the second one, z equal to 18 times 15 plus 9 times 20, and when we simplify we will get 450 as the answer here. And taking the point 40, 15, the value of z will be 18 into 40 plus 9 into 15. When we simplify, we will get 855. So we need to know what is the maximum value and what is the minimum value of the given objective function. So by seeing itself we can say 450 is the minimum value and 855 is the maximum value. So who gave the minimum value? 15, 20, and which point gave this maximum value? 40, 15. So looking at the options given, we can say that z is maximum at 40, 15, minimum at 15, 20. That is the correct choice. So option C is the correct answer. Let us move on to the next sum. If A and B are invertible matrices, then which of the following is not correct? We know that A into B inverse equal to B inverse into A inverse. This is correct. And we know that A inverse equal to 1 by det A into adjoint of A. So Det A into A inverse equal to HA is also correct statement. And we also know that det of A inverse equal to det of A inverse. This is also correct statement. So the first one, there is nothing like the first one. A plus B inverse equal to B inverse plus A inverse. So option A is the non-correct option. So let's move on to the next sum. If the feasible region of a linear programming problem with objective function z equal to ax plus by is bounded, then which of the following is correct? So for you to understand, let me randomly draw something. Suppose if we have some line like this and another line going like this. So if we are getting this is our feasible region, for example, which is a bounded region, and we will have the corner points, correct? So 1, 2, 3, 4. So according to this example, we have 4 corner points. So eventually our function, this objective function, will have one maximum value as well as minimum value. So feasible region is bounded, then objective function takes finite values within that region. So it will reach its highest and the lowest values at the corner points for sure. So it has both the maximum and minimum values. So option C is the correct answer. Let's go to the next sum. The area of the shaded region bounded by the curves y square equal to x, x equal to 4 and the x-axis is given by, we need to find that. So one thing we have to know is, if we have the function going like this and we are taking the boundary for x equal to a and x equal to b, then we should find this area by doing integral a to b, the limits which are given for x, and when the limits of x are given, we need to do dx. So y we have to take and do the integration between the limits. So coming to this function, the starting point for x is 0 here, x equal to 0, and x equal to 4 is the end point here. So limits for x is given. So therefore area will be equal to y dx between the limits x equal to 0 and x equal to 4. So they have given the value for y square. So we need to find the value of y by applying square root on both sides. So we will get y equal to root x. So the area will be 0 to 4 root of x dx. So the correct answer is option D. Let's move on to the next sum. The graph of a trigonometric function is as shown. Which of the following will represent graph of its inverse? So one thing you have to understand is, if f is a function from the set A to set B, then f inverse will be a function from set B to set A. So the function f will be having one element from A and its image will be in B. So if we take the element of capital A like small a and the element of capital B like small b, then every element in the function f will be having a comma b as the point format. So for f inverse, it is the reverse, b comma a. So keeping that in mind, look at the given image. So this point, the first point where I am keeping the dot, is nothing but minus pi by 2 comma 0, because y value should not be there because that point is an x-axis point. So y value will not be there. And look at this point. This point is lying on the y-axis and there is no x value. So it can be 0 comma 1 because x is not there, right? And look at this point. This point again lies in the x-axis. So you can consider this point like pi by 2 comma 0. And look at the next point. X is pi and y value is exactly at the same distance like this point. So you can consider this point like minus 1 in y-axis. So you can consider this point like pi comma negative 1. So these are the 4 points we have. For the function f's graph, what are the points we have? Minus pi by 2, 0 and 0, 1 and pi by 2, comma 0 and pi comma negative 1. So what are the points in f inverse's graph? Just reverse the coordinates of the ordered pair. So 0 comma negative pi by 2 and 1 comma 0 and 0 comma plus pi by 2 and minus 1 comma plus pi. So keeping this in mind, you have to check all the 4 graphs given to you and you have to pick up which one is having these 4 points exactly. So seeing the graph C, see what is this point here? See, it is x value is minus 1 and y value is pi, right? So this particular point is minus 1 comma pi. And look at this point. Now this point lies in the y-axis. So this point can be considered like 0 comma pi by 2. And look at the third point here. This is lying in the x-axis. So this can be like 1 comma 0. Now look at our f inverse's coordinates here. Minus 1 comma pi, 0 comma pi by 2, 1 comma 0. So these are the 3 points which we have for the graph of C. So graph C is the graph of the inverse of the given trigonometric function. So option C is the correct answer. Let's go to the next sum. Assertion A, let Z be the set of integers. A function f from Z to Z defined as f of x equal to 3x minus 5 for all x belong to Z is bijective. So what do you mean by bijective function? A function which is injective and surjective. Or we can consider a function which is one-to-one and onto. That is our bijective function that we have to check here. So what is the method to check the injectivity of a function, right? Injectivity. So how to do that? We have to consider f of x1 equal to f of x2 and we have to arrive at x1 equal to x2. So let us see, when f of x equal to 3x minus 5, f of x1 will be 3x1 minus 5 and f of x2 will be 3x2 minus 5. So taking this minus 5 to the other side, we have 3x1 equal to 3x2 minus 5 plus 5. These two will cancel each other. So we get 3x1 equal to 3x2. So this will imply x1 equal to x2 by cancelling 3 on both sides. See, we started with f of x1 equal to f of x2 and we arrived at x1 equal to x2. That implies f of x is 1-to-1 or injective function. No doubt about that. Now we need to check the onto nature of the function. For that, what we will do? We will take one element from the codomain. The codomain is also Z here. See, let us draw the arrow diagram. So this is our domain and this is our codomain. So domain and this is our codomain. So suppose if I take 1 in the codomain, what will be that element which gave mapping to this one? Yeah, so f of x equal to 1. I want to know what is that x here. So 3x minus 5, that is our f of x's value, that should be equal to 1. So this will give you 3x equal to 1 plus 5, 6, x equal to 2 and x equal to 2 is possible because set of integers only we have that 2. Suppose if I take the element 2 And if I want to know who gives mapping to this particular 2, yeah, maybe we call this like x1, and who was that x2 giving mapping to this 2. Yeah, so let us consider the same way. So we take 3x2 minus 5 equal to 2. Then 3x2 equal to 7, x2 equal to 7 by 3, which is a rational number or a decimal number which won't be available in our set of integers. Correct? So x2 cannot take one rational value, which is wrong. So 2 is not receiving any mapping from any of the elements from the domain set. So that means I have one particular entry in the codomain who is not receiving any mapping from the elements of the domain. So we can't say this is onto, right? When can we say onto? When every element in the codomain receives mapping from the elements in the domain, then only it is onto. At least if one element is not receiving any mapping, we can't agree. So F is not onto. That is our conclusion. So surjectivity is not obeyed, only injectivity is obeyed. So here they are saying bijective function, which is false. And look at the reason now. A function is a bijective function if it is both surjective and injective, which is perfectly fine. So the reason is true and the assertion is false. So option D is the one we have to pick up for when the assertion is false and reason is true. Okay, now let us go for 20th sum. Assertion is given like f of x equal to 3x minus 8 when x is less than or equal to 5, equal to 2k when x is greater than 5, is continuous at x equal to 5 for k equal to 5 by 2. So we have to solve this only, then only we will come to know whether it is true or false. So when can you say a function f of x is continuous at a given point? Limit x tends to a minus fx equal to limit x tends to a plus fx equal to f of a for some particular a, then we can say f of x is continuous at that particular point a. Now let us think about x equal to 5 here. So we can accept that f of x is continuous only when we have limit x tends to 5 minus fx equal to limit x tends to 5 plus fx equal to f of 5. So we need to check this. First let us find the left limit. So limit x tends to 5 minus fx, you know that we can find limit h tends to 0 f of 5 minus h for this. How? Because when we take 5, its neighborhood we have to consider, which is 5 minus h comma 5 plus h, and when we find the left limit we have to take the left extremes limit as h tends to 0. Because when h becomes 0, 5 minus h will merge with 5. So that's why we can do this way. So this is equal to limit h tends to 0 f of 5 minus h. Where can I find f of 5 minus h? Because f of x is taking two different values, right? So when 5 minus h is less than 5, we know this. So we are in this zone, because whenever x is below 5, we have to take f of x equal to 3x minus 8. So in this zone, we have to take this particular f of x for our reference. So in this only, we need to find our f of 5 minus h, isn't it? So this will give you 3 times 5 minus h minus 8. So this is nothing but 15 minus 3h minus 8. And 15 minus 8 is 7. 7 minus 3h is our f of 5 minus h. So that I am writing here. Limit h tends to 0, 7 minus 3h. And this will give you 7 minus 3 times 0, because this is the direct application type of limits, right? So we can directly put h equal to 0. So this gives you 7 as the answer. So the left limit is 7. Now let us see what is the right limit. Limit x tends to 5 plus fx equal to limit h tends to 0 f of right end of the neighborhood, 5 plus h. So we know that 5 plus h is bigger than 5. So we are in this zone now. So f of x takes 2k as the answer. So this will be limit h tends to 0, 2k. So this will be 2k only because there is no h to put 0 there. So the right limit is 2k. And what is f of 5 here? When x equal to 5, it is also included here. So f of 5 will be 3 times 5 minus 8 because we have to take f of x equal to 3x minus 8 here. So this will give you 15 minus 8, which is 7. So when we take the left limit equal to right limit equal to f of 5, we will have 7 equal to 2k equal to 7. This will give you 2k equal to 7, k equal to 7 by 2. That's the correct answer. So looking at the given k, they have given k equal to 5 by 2, which is the wrong answer. So assertion is false here. And look at the reason here. For a function f to be continuous at x equal to a, limit x tends to a minus fx equal to limit x tends to a plus fx equal to f of a, which is the definition for a function being continuous, which is all true. So here also assertion is false and reason is true. So here also the correct answer is option D. Next we have section B, very short answer type, 2 marks each. So option number 1 is differentiate 2 power cos square x with respect to cos square x. So here let t equal to cos square x because we are going to differentiate with respect to cos square x. So we are taking t equal to cos square x as the substitution. So let us take the given value like our y equal to 2 to the power cos square x. So this will now become 2 power t. Correct? So now we can only find out dy by dt. dy by dt is nothing but 2 power t into log 2. The reason is d by dx of a power x equal to a power x log a. Now we can replace our substitution. This will give you 2 power cos square x into log 2 as the answer. Let's do the option B in sum number 21. If tan inverse of x square plus y square equal to a square, then find dy by dx. So let us take the given thing, tan inverse of x square plus y square equal to a square. This is given. So having the inverse function, we can't be able to differentiate it easily because we know that tan inverse x's derivative will be 1 by 1 plus x square. So it will be, when you directly differentiate this, you will get 1 by 1 plus this value and then this guy's differentiation again. So that will complicate the problem. We are going to apply a shortcut here. We can apply tan on both sides of the given value. So tan inverse of x square plus y square equal to tan a square. So that implies x square plus y square because tan and tan inverse cancel each other. X square plus y square equal to tan a square. Now we can differentiate it nicely with respect to x. So on differentiating with respect to x, we get 2x plus 2y into dy by dx equal to 0 because a square is a constant. So tan of a square is also another constant. So derivative of a constant is 0. And when we divide both sides with the 2, we get x plus y times dy by dx equal to 0 by 2 is also 0. So y times dy by dx equal to negative x. So dy by dx equal to negative x by y. That is the required answer. Let's move on to the next sum. Question 22. Evaluate tan inverse of 2 sine of 2 cos inverse of root 3 by 2. first of all we have to go from the innermost bracket towards the outer bracket. So first let us take cos inverse of root 3 by 2 equal to some theta. So that implies applying cos on both sides. We have cos of cos inverse root 3 by 2 equal to cos theta. That implies root 3 by 2 equal to cos theta. So when we draw the right angle triangle with theta being here, cos theta is nothing but base by hypotenuse. So we can take the base like root 3k and the hypotenuse like 2k, and we need to find out the missing side here. So when we do the Pythagoras theorem applied, we get root 3k whole square plus that missing side square equal to 2k whole square. This gives us 3k square plus missing side square equal to 4k square. So the missing side square equal to 4k square minus 3k square, 1k square. So the missing side will be just a k. So now let us consider 2 times cos inverse root 3 by 2. That will become 2 times theta. Now we need to find out 2 sin of 2 cos inverse root 3 by 2. This will be 2 sin of 2 theta. And this can be written like 2 into 2 sin theta cos theta, because you guys know sin 2 theta is 2 sin theta cos theta. And this will be like 4 times sin theta cos theta. And that will be 4 times sin theta is perpendicular by hypotenuse, which is k by 2k, into cos theta we already know root 3 by 2. So this becomes k cancels here, 4 into root 3 divided by 4, which is just a root 3. Now tan inverse of 2 sin of 2 cos inverse root 3 by 2 equal to tan inverse of, the answer for 2 sin of 2 cos inverse root 3 by 2 is already here, which is root 3. So tan inverse of root 3, this can be written like tan inverse of tan 60, right? Tan 60 is root 3. So tan inverse of tan 60. So 60 degree is the answer. Pi by 3 is the answer. Let's move on to the next sum. Sum number 23. The diagonals of a parallelogram are given by vector A equal to 2i minus j plus k and vector B equal to I plus 3j minus k. Find the area of the parallelogram. So let this be the parallelogram ABCD, in which the AC diagonal is vector A and BD diagonal is vector B. We need to find the area of the parallelogram. So we know by the definition of area of a parallelogram, if the diagonals are given, then its area will be, area of the parallelogram will be half times the magnitude of the cross product of the diagonals. First we need to find the cross product of the diagonals, and then we have to find the length of that. So first let us find A cross B's value, which is the determinant ijk. Components of vector A are 2 minus 1 and plus 1, and components of vector B are 1, 3 and minus 1. Now expanding this determinant, we have I cap into its minor minus 1, 1, 3 minus 1, minus j cap into its minor is 2, 1, 1 minus 1, plus k cap into its minor is 2 minus 1, 1, 3. So when we simplify, we get minus 1 into minus 1 plus 1 minus 3 into 1, 3, minus j cap into 2 into minus 1 minus 2 minus 1 into 1, 1, plus k cap into 2 into 3, 6, minus of 1 into minus 1, minus 1. So this will be minus 2 I cap plus 3 j cap plus 7 k cap. and now we need the magnitude of A cross B. So magnitude of A cross B will be square root of minus 2 whole square plus 3 square plus 7 square. This will be square root of 4 plus 9 plus 49, and this will be square root of 49 plus 9 is 58, 58 plus 4 is 62, square root of 62. Therefore, area of parallelogram ABCD will be half the times root of 62. We cannot break root of 62 further, so we cannot simplify this further. This is the final answer. So area, so write square units without fail. Let's move on to the next sum. Sum number 24. Find the intervals in which the function f of x equal to 5x power 3 by 2 minus 3x power 5 by 2 is increasing and decreasing. For checking a given function, whether it is increasing or decreasing, we need to find the critical points of the function, and then we have to take the entire domain of the given function, split into the regions using the critical points, and we have to discuss the nature of the function in all those regions. So let us see one by one. First, we are going to find out the critical points of f of x, for which we need to find out f dash of x and then set it equal to 0. So let us find out f dash of x first. It will be 5 into the differentiation for x power 3 by 2 is 3 by 2 x power 3 by 2 minus 1 minus 3 into the differentiation for x power 5 by 2 is 5 by 2 x power 5 by 2 minus 1, and this will be 5 into 3 by 2 x power 1 by 2 minus 3 into 5 by 2 into x power 5 minus 2 by 2 is 3 by 2. And simplifying this further, we have 15 by 2 x power 1 by 2 minus 15 by 2 x power 3 by 2. Let f dash of x equal to 0. That implies 15 by 2 into x power 1 by 2 minus x power 3 by 2. We can take 15 by 2 common, right? So 15 by 2 into x power 1 by 2 minus x power 3 by 2 equal to 0. Obviously, 15 by 2 cannot be 0. So x power 1 by 2 minus x power 3 by 2 should be equal to 0. And we very well know that x power 1 by 2 is root x and x power 3 by 2 is root x into x. So that is equal to 0. So we can take root x common, then we get 1 minus x equal to 0. This implies either root x equal to 0 or 1 minus x equal to 0. This gives us, on squaring both sides, we get x equal to 0 for the first thing or x equal to 1 in the next. So we have two critical points for our this given f of x. So you can very well see that the domain for this f of x is all possible real values, right? X can take all possible real values here, because we are not going to get any indeterminate form or undefined when we take any real number for x. So the domain is the set of real numbers. So let us draw the number line here, and the critical points are like this. So the critical points are splitting the real zone into so many intervals, isn't it? So we need to test the nature of our f of x in all these three zones by taking some value for x in the given intervals. So this is minus infinity to 0, and this is 0 to 1, and this is 1 to plus infinity. These are the three intervals we have. So let us take any value in these zones. For example, when we take any value from the interval 0 to 1, let us see what happens to f dash of x. So for example, we can take half equal to x, right? So f dash of x will be 15 by 2 into half power 1 by 2 minus half power 3 by 2, because we can replace our f dash of x with the value x equal to 1 by 2 in this. So this will give you 15 by 2 into root over 1 by 2 minus 1 by 2 times root over 1 by 2. And this is nothing but 15 by 2 into root over 1 is 1 only. So 1 by root 2 you can take common outside. And this is 1 minus 1 by 2, which is also 1 by 2 only. So 15 by 2 into 1 by root 2 into 1 by 2, which is 15 by 2 times 1 by 2 root 2, which is a positive quantity. So f dash of x is having a value greater than 0. That means the function f of x is increasing in the interval 0, 1. So f of x is increasing in 0, 1. Now let us take the interval minus infinity, 0, and we can pick up any one point in this particular interval. So we can take minus 1 here. Okay, so now we know that f dash of x equal to 15 by 2 into root x into 1 minus x. So when we put minus 1 here, f dash of minus 1 equal to 15 by 2 into root of minus 1 into 1 minus of minus 1. And this will be 15 by 2 into root over minus 1 into 1 minus of minus 1 is 1 plus 1, which is 2. These two 2's will cancel. So 15 into root of negative 1. So this is giving you one imaginary value. So we cannot say whether this is bigger than 0 or lesser than 0. So we cannot consider the interval minus infinity, 0. So it cannot be determined. Now let us consider the interval 1, infinity. We can pick one point from there. So suppose if we take 4, which is lying in between 1 and infinity, let us see f dash of x equal to again 15 by 2 into root x into 1 minus x. So f dash of 4 will be 15 by 2 into root over 4 into 1 minus 4. This will give you 15 by 2 into 2 into minus 3. So this will give you 15 into minus 3 minus 45, which is less than 0. So f of x is decreasing in the interval 1, infinity. So we can say f of x is increasing in the interval 0, 1, and f of x is decreasing in the interval 1, infinity, and we cannot determine whether f of x is increasing or decreasing in the interval minus infinity to 0. Let's go to the next sum. So 25th sum has two options. So let's see the first option. Two friends, while flying kites from different locations, find the strings of their kites crossing each other. The strings can be represented by vectors a equal to 3i plus j plus 2k and vector b equals 2i minus 2j plus 4k. Determine the angle formed between the kite strings. Assume there is no slack in the strings. So suppose if first from friend number A is here, who is flying the kite like this. Suppose if this is friend B, who is flying the kite like this. So these strings are crossing each other at a particular point, this point. So now this one is given like vector A and this one is given like vector B. Now we need to find the angle between vector A and vector B. Let theta be the angle between the vectors A and B. We have to take only the acute angle between them. So this is the angle between A and B. So cos theta will be A dot B divided by length of A into length of B. First let us find A dot B. A dot B equal to 3I plus J plus 2K dot 2I minus 2J plus 4K. This will be 3 times 2 plus 1 time minus 2 plus 2 times 4. This is 6 minus 2 plus 8, which is 12. Now length of A vector will be root over 3 square plus 1 square plus 2 square, which is root over 9 plus 1 plus 4, which is root over 14. And length of vector B equal to root of 2 square plus minus 2 square plus 4 square, which is root over 4 plus 4 plus 16, which is root over 24. So now let us find the value of cos theta. So cos theta equal to A dot B's answer is 12 divided by length of A is root 14 and the length of B is root 24. And this we can write like 12 divided by root of 14 into 24. And this will be 12 divided by, you can factorize 14 and 24 to take the square root of them. So 14's prime factorization is 2 into 7 and 24's prime factorization is 2 into 2 into 2 into 3. So this will be 12 divided by, for there are 4 2's, so we can take 2 2's outside, and 7 and 3 cannot come, so root of 21, 7 3's are 21, that will stay inside the root only. So this is like 12 by 4 root 21, which is 4 and 12 can be cancelled 3 times, so 3 by root over 21. So cos theta equal to 3 by root over 21. So theta equal to the angle between the strings equal to cos inverse of 3 by root of 21. Let us move on to the second option of question 25. Find a vector of magnitude 21 units in the direction opposite to that of AB vector, where A and B are the points 2, 1, 3 and 8, minus 1, 0 respectively. First of all, what we have to do is, we have to find a unit vector in the direction of BA vector, because we want the vector in the direction opposite to that of AB. So a vector which is opposite in direction of AB will be BA vector. So we can find out BA vector. Vector BA is equal to OA minus OB. So we can easily find the position vectors of A and B using the points given, right? So this is like 2I plus 1J plus 3K minus OB vector will be 8I minus 1J plus 0K. So the final answer for this is 2 minus 8 is minus 6I, 1J plus 1J will be 2J, 3 minus 0 will be 3 only. So this is our BA vector. Let us find the unit vector in the direction of BA vector. So for that we need the magnitude of BA vector. So magnitude of BA vector is equal to root of minus 6 square plus 2 square plus 3 square, which is root of 36 plus 4 plus 9, which is 40 plus 9, 49, which is 7. Therefore, a unit vector in the direction opposite to AB vector is equal to BA vector divided by length of BA vector, which is minus 6I plus 2J plus 3K divided by 7. Now we want a vector whose magnitude is 21 units. For required vector of magnitude 21 units in the opposite direction of AB vector will be 21 times BA vector by length of BA vector. So this will be 21 times minus 6i plus 2j plus 3k divided by 7. We can cancel this 7 and 21 3 times. So the final answer is equal to minus 18i plus 6j plus 9k. So the final answer is minus 18i plus 6j plus 9k. Let us solve section C, short answer type, 3 marks each. Sum number 26. The side of an equilateral triangle is increasing at the rate of 3 centimeters per second. At what rate its area increasing when the side of the triangle is 15 centimeter? Let A be the side of the equilateral triangle. So given that dA by dt equal to 3 centimeters per second. This is given. Right? Now what we need to find is rate of change of area. D capital A by dt we need to find out. We know that area of the equilateral triangle is A equal to root 3 by 4 A square. It's a formula, right? Now we can only differentiate with respect to small a only. So dA by d small a will be root 3 by 4 into A square's derivative is 2a. And we can cancel this 2 and this 4. So we get root 3a divided by 2. But we wanted d capital A by dt. So by applying chain rule, we can write this like d capital A by d small a times d small a by dt. So this will be root 3a by 2 into dA by dt's value is 3, right? So this will become 3 root 3a divided by 2 centimeter square per second, because this is area with respect to time. Now they are asking us the value of dA by dt when side of the triangle is, small a is 15 centimeters. So dA by dt when a is 15 centimeter will be 3 root 3 into 15 divided by 2, which is 45 root 3 divided by 2 centimeter square per second. That's the final answer. Let's move on to the next sum. Solve the following linear programming problem graphically. Maximize z equal to x plus 2y subject to the constraints x minus y greater than or equal to 0, x minus 2y greater than or equal to minus 2, x greater than or equal to 0, y greater than or equal to 0. So these two are the positivity constraints. Right? Now we need to draw two lines here. What are they? X minus y equal to 0 and x minus 2y equal to minus 2. You guys know how to draw the lines, right? You have to have at least 2 points on the line, then we can be able to plot those lines. So to know the 2 points, we can take x equal to 0 and y equal to 0. For the first line, x equal to y. So we can take random points on this line, like if x equal to 2, then y is equal to 2. You can take some other point. So if x equal to 4, then y is also equal to 4. So the points can be 2, 2 and 4, 4. We are naming the points like A and B. The same way, the next line, if we take x equal to 0, then 0 minus 2y equal to minus 2. That implies minus 2y equal to minus 2. That implies y equal to minus 2 by minus 2 plus 1. So 0, 1 is a point on the line. We can call this point like C. Same way, if we take y equal to 0, then x minus 2 times 0 equal to minus 2. So that implies x equal to minus 2. The point will be minus 2 comma 0, which is the point D. So I have taken graph sheet and I have drawn both the lines. So this is the first point we have taken for the first line 2 comma 2, and this is the next point we got for the first line 4 comma 4. So this is our capital A point, this is our capital B point. And for the next line we got 0 comma 1, this is the point C we had 0 comma 1, and this is the point D we had minus 2 comma 0. So we have taken the points and we drew the lines. Next we need to find out the feasible region. So first let us take the first inequality. So x minus y greater than or equal to 0. That implies x is greater than or equal to y. To know which side of the line we can take for our feasible region, you can try giving some random values for x and y. If we take the point 4 comma 2, can we have x greater than or equal to y satisfied here? Of course yes, right? So 4 greater than 2 only. So 4 comma 2 satisfies the inequation. So we have to draw down arrow for the red colored line here, the line x equal to y. Then for the blue line, this inequality is x minus 2y greater than or equal to minus 2. So we can take origin for our reference. So when we put 0 0 for x and y, we get 0 minus 2 times 0, which is also 0. 0 minus 0 greater than or equal to minus 2. 0 greater than minus 2 is true, right? So that means the side which contains the origin will be the feasible region for the blue line. So this zone above the blue line is not the feasible region, the zone which contains our origin. So we have to draw the arrow like here, below the blue line. That is our required feasible region. So you know that since both the lines are showing the arrows to the downside of the lines, this yellow colored region is the feasible region, which is an unbounded region right now. So when we get the unbounded region as our feasible region, what we have to do is we have to find the corner points of the unbounded region. So what are the corner points here? The yellow region touches the lines only at the origin and 2 comma 2, right? Only 2 points are the corner points, right? So our origin is one corner point, O is the corner point, and another point is 2 comma 2, which we have named like A, right? So we need to find the value of z at both these points. Since z equal to x plus 2y, when we put origin in z value, we get z equal to 0 plus 2 times 0, which is going to give us 0. When we take a 2 comma 2 and substituting in our z, we get 2 plus 2 times 2, which is 2 plus 4, 6. So right now 6 is the maximum point, but we want to know what is the maximum most value that z can take, because we have unbounded region as our feasible region. So to make this idea clearly found, what we have to do is take your z x plus 2y, and right now we found 6 is the maximum value of this guy. So first we have to draw this line x plus 2y equal to 6, this line, and we have to know which side is having the inequation like x plus 2y bigger than 6. This is getting satisfied. Okay, so for that what we have to do is we have to draw that x plus 2y equal to 6 line. You know well how to draw this line. So when you take x equal to 0, 2y, 0 plus 2y, which is 2y, equal to 6. So y equal to 3. So this green dotted line passes through this point 0, 3. When you take y equal to 0, we get x plus 0 equal to 6. That means x equal to 6. So this green dotted line passes through 6, 0. That's how we drew this green dotted line. Right? And this line also passes through 2, 2, our maximum point. Okay, now which side of this dotted line has the maximum value for our objective function? That we need to find out. I mean, we need to know which side of this line has x plus 2y more than 6. So, for that you take some random point over here. Suppose if we take the origin side, origin is below the green dotted line, right? So, when we take origin and check this inequality, we have 0 plus 0 greater than 6, which is not true. So, origin side is not the feasible region for this inequation. So, we have to choose the above side of this green dotted line. So, that's how we have drawn this up arrow towards the side which doesn't contain the origin. So, when we draw that, this green dotted region is our feasible region according to this green dotted line. One thing we have to understand is, when our feasible region is one unbounded region, this green dotted line, if you want to maximize it, it should not have any common zone with the yellow shaded region. I mean, the green dotted region and the yellow shaded region should not have any overlaps. But in this sum, we are having overlaps. So, what is our conclusion is, since there is overlap between the green dotted region and the yellow shaded region, we should conclude that Z has no maximum value. Or you can say Z cannot be maximized, because each and every point will give you one more maximum value than the previous one. For example, if we take 9, 3 for our point of reference, Z will be having one value. If you take some other point here, it will give you even more bigger value for Z. So it will keep on increasing up to infinity. So Z has no maximum value according to the graph. That's the conclusion. Let's go to the next sum. Sum number 28a. Find integral x plus sin x by 1 plus cos x. Here we are going to use the half angle formulas for sin x and 1 plus cos x. And we know that sin x equal to 2 sin x by 2 cos x by 2, and 1 plus cos x equal to 2 cos square x by 2. So, let us take the integral x plus sin x divided by 1 plus cos x dx, which is equal to x plus the value of sin x we can use here, 2 sin x by 2 cos x by 2 divided by 2 cos square x by 2. Now, as you can see, we can split this into two integrals, like x by 2 cos square x by 2 dx plus integral 2 sin x by 2 cos x by 2 divided by 2 cos square x by 2 dx. So this will become 1 by 2 can be taken out, integral x divided by cos square x into 1 by cos square will be x into secant square, right? 1 by cos square is secant square. So x into secant square x by 2 dx plus here 2 cancels and one of the cos values cancel. So we get sin x by 2 by cos x by 2, which is tan x by 2, dx. And this first integration, we have to apply the integration by parts. By 2, x is our first function and secant square x by 2 is our second function. So u equal to x and dv equal to secant square x by 2 dx, and integration of this will be integration of secant square x by 2 dx, and differentiation of this will be simply dx. Tan x by 2 by 1 by 2, which is 2 tan x by 2. So the answer for the integration is integral x plus sin x by 1 plus cos x dx will be 1 by 2 into first function and the integral of the second function, which is 2 tan x by 2 minus integral second function's integration into first function's differentiation dx. And there is another value after this, which is integral tan x by 2 dx. So this will give you 1 by 2 into x into 2 tan x by 2. Both the 2's will cancel. We get x tan x by 2. And 1 by 2 into 2, that will cancel, minus integral tan x by 2 dx. And the third one is integral tan x by 2 dx. And this is minus tan x by 2, this is plus tan x by 2, both will cancel. So the final answer is x tan x by 2 plus constant of integration. That's the final answer. Let's do the next sum. 28b sum. Evaluate integral 0 to pi by 4 dx divided by cos cube x into root of 2 sin 2x. Let us take the value 1 by cos cube x into root of 2 sin 2x. This can be written like 1 by cos cube x into root of 2 into sin 2x value is 2 sin x cos x. And this will be 1 by cos cube x into root of 4 sin x cos x. And this will be 1 by root 4 is 2, so we can take it outside, cos cube x into root of sin x cos x. Let's multiply and divide by a cos x in the denominator. So we get 2 cos cube x root of sin x into cos x by cos x into cos x. So this will give us 1 divided by 2. This cos cube x and this cos x will multiply to give you 2 cos power 4x into root of sin x into cos x divided by this denominator cos x we can write like root of cos square x, because root cos square is cos. So this will be 1 by 2 cos power 4x. These two root values we can combine together. Root of sin x cos x divided by cos square x. And one of the cos values will cancel. So we get 1 by 2 cos power 4x into root of sin by cos will be tan x. Now this is like 1 by 2 into 1 by cos power 4x into 1 by root of tan x. And this will become 1 by 2 into 1 by cos power 4x will become secant power 4x into 1 by root of tan x. And this secant power 4x can be split like secant square x into secant square x. into 1 by root of tan x. And 1 of this secant square x we are changing to 1 plus tan square x. The other secant square x we are keeping as it is. And this divided by root tan x. So that is the simplification we can give for the value inside the integral. Now we can take the integration together. Integral 0 to pi by 4 dx divided by cos cube x into root of 2 sin 2x was the given integral. So now we can write our last step we have found. That 1 by 2 can be taken out. Rest of the things we can write inside the integral. 1 plus tan square x into secant square x divided by root of tan x dx. Now we are going to do substitution here. Put tan x equal to t. So that implies secant square x dx will be dt. And we need to change the limits also, right? So when x equal to 0, t equal to tan x. X is 0. So tan 0. Tan 0, 0. So the lower limit is 0 only. So when x equal to pi by 4, t equal to tan pi by 4, and tan pi by 4 is tan 45, which is 1. So now the limit becomes 0 to 1. 1 plus tan square is 1 plus t square, and secant square x dx is dt divided by root of tan x is root of t. Now this we can split into two integrals. 1 by 2 integral 0 to 1, 1 by root t dt plus 1 by 2 integral 0 to 1 t square divided by root of t dt. And this will be 1 by 2 integral 0 to 1 t power minus 1 by 2 dt, because root t is t power 1 by 2. And the next one is 1 by 2 integral 0 to 1 t power 2 minus 1 by 2 dt, because root t is t power 1 by 2. So this will be 1 by 2 into t power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 between the limits 0 and 1. And the next one is 1 by 2. 2 minus 1 by 2 is 3 by 2. So t power 3 by 2's integration is t power 3 by 2 plus 1 by 3 by 2 plus 1 between the limits 0 and 1. So this becomes 1 by 2 t power plus 1 by 2 by 1 by 2 between 0 to 1 plus 1 by 2 into t power 5 by 2 by 5 by 2 between the limits 0 and 1. So this will give us 1 by 2 into, when t is 1, 1 power 1 by 2 is 1 only. So 1 by 1 by 2 is 2 minus, when 0 we put 0 by anything 0 only. Then the next value will be 1 by 2 into 1 power 5 by 2 is 1 only. 1 by 5 by 2 is 2 by 5 minus, when we put t equal to 0 we get a 0. So this is 1 by 2 into 2, which is 1, plus 1 by 2 into 2 by 5 is 1 by 5, and their sum is, taking 5 as LCM, we get 5 plus 1 by 5, which is 6 by 5. That's the answer. Let us solve sum number 29. There are two options here. Option A, verify that lines given by r vector equal to 1 minus lambda times I plus lambda minus 2 times j plus 3 minus 2 lambda times k, and r vector equal to mu plus 1 times I plus 2 mu minus 1 times j minus 2 mu plus 1 times k are skew lines. Hence find shortest distance between the lines. We know that the general equation of the vector form of the lines will be in this format, right? L1 is, line 1 will be r bar equal to a1 bar plus lambda times b1 bar, and line 2 will be r bar equal to a2 bar plus mu times b2 bar. You guys know that b1 and b2 are the vectors which are parallel to the given line 1 and line 2 respectively, and a1 bar and a2 bar are the component form of the points through which these lines are passing by, right? So in this case, the formula for finding the shortest distance between these two lines will be modulus of a2 bar minus a1 bar dot b1 bar cross b2 bar divided by length of b1 bar cross b2 bar. So this is the shortest distance between the lines. So we have to find out the needed things. Let us write the line 1 given to us. 1 minus lambda time I plus lambda minus 2 times j plus 3 minus 2 lambda times k. And we can split this like 1 into I minus lambda I plus lambda j minus 2j plus 3k minus 2 lambda k. And separating the lambda terms and non-lambda terms, we get I minus 2j plus 3k plus lambda times minus I plus j minus 2k. So these are the lambda related items, right? So taking lambda outside, we get minus I plus j minus 2k. So you can very well say that this is our a1 vector and this is our b1 vector. And for line 2 also we need to do the same. Mu plus 1 I vector plus 2 mu minus 1 times j minus 2 mu plus 1 time k. We can open this like mu I cap plus I cap plus 2 mu j cap minus j cap minus 2 mu k cap minus k cap. Here also we need to separate out the mu terms and non-mu terms. So we will get I minus j minus k plus mu times I plus 2j minus 2k. So this is our a2 vector and this is our b2 vector. So first we need to calculate a2 minus a1 and then b1 cross b2 and then length of b1 cross b2, then only we can find the shortest distance. So first a2 minus a1 vector will be I minus j minus k, that is a2, minus a1 vector is I minus 2j plus 3k. Okay, subtracting we get I minus I is 0, minus j minus of minus 2j is minus j plus 2j, which will give you plus 1j, minus k minus 3k will give you minus 4k. Now we need to find out b1 cross b2, which is obtained by finding the determinant I, j, k. Coefficients of b1 vector will be minus 1, 1 and minus 2, and the coefficient of b2 vector will be 1, 2, minus 2. So expanding this determinant, we get I into minor of I is 1 minus 2, 2 minus 2, minus j into minor of j is minus 1 minus 2, 1 minus 2, plus k into minor of k will be minus 1, 1, 1, 2. And the answer for this is I times minus 2 minus of minus 4 minus j into plus 2 minus of minus 2 plus k into minus 2 minus 1. So this will be I into minus 2 plus 4, which is 2, minus j into 2 plus 2, 4, plus k into minus 3, which is 2i minus 4j minus 3k. Now we need to do a2 minus a1 dot b1 cross b2, and we need to find the modulus of this also. So the dot product between a2 minus a1 and b1 cross b2 will be j minus 4k dot 2i minus 4j minus 3k. Since I is not there in the first vector, it is 0i. So 0 into 2 plus j's coefficient is 1 here, minus 4 here, and k's coefficient is minus 4 here, minus 3 there. So the final answer will be minus 4 plus 12, which is 8. So it is positive only, plus 8 only. Now we need the length of b1 cross b2 vector also. So length of b1 cross b2 will be square root of 2 square plus minus 4 square plus minus 3 square. This will be 4 plus 16 plus 9, and this will be root of 29. So shortest distance will be the modulus of a2 minus a1 dot b1 cross b2 divided by length of b1 cross b2, which is 8 divided by root of 29. So you have to conclude shortest distance is 8 by root 29 units. Let's do the next option of this sum. During a cricket match, the position of the bowler, the wicket keeper, and the leg slip fielder are in a line given by vector b equal to 2i plus 8j, vector w equal to 6i plus 12j, and vector f equal to 12i plus 18j respectively. Calculate the ratio in which the wicket keeper divides the line segment joining the bowler and the leg slip fielder. So B means the bowler, and W means the wicket keeper, and F means the fielder. So wicket keeper is in the middle, right? Wicket keeper divides the line segment joining the bowler and the leg slip fielder. So as usual, we have to keep the ratio in which W divides BF line segment is k:1. Let W vector divides the line segment BF in the ratio k:1. So we know the section formula for internal division for vectors, right? Therefore, W will be k times F vector plus 1 time B vector divided by k plus 1. So this will be k times F vector is 12i plus 18j plus 1 time B vector is 2i plus 8j divided by k plus 1. W's value is of course 6i plus 12j. And simplifying this further, we get 12ki plus 18kj plus 2i plus 8j divided by k plus 1. And this will be equal to, there are two I values, we can add them together. 12k plus 2, both are I vector related items, and 18k plus 8 j vector j divided by k plus 1. So this we can write like 12k plus 2 by k plus 1 vector I plus 18k plus 8 divided by k plus 1 vector j. As we know, if two vectors are equal, then their corresponding components will be equal to each other. So comparing the values on both sides, we can say 12k plus 2 by k plus 1 equal to coefficient of I is 6 on the left side, and 18k plus 8 by k plus 1 is equal to 12 because j's coefficient is 12 on the other side. So we can solve these two equations. So 12k plus 2 equal to 6k plus 6 by cross multiplying 6 and k plus 1. So this will give you 6k equal to 4, k equal to 4 by 6, which is 2 by 3. Same way we have to make sure whether we are getting the same answer for the other relation also. So it is 18k plus 8 equal to 12k plus 12. So 6k equal to 12 minus 8, which is 4, k equal to 2 by 3 only. So we are getting the same answer in both. So the ratio in which the wicket keeper divides the line segment joining the bowler and the fielder is 2 by 3 is to 1, which can be said 2 is to 3. So W divides BF in the ratio 2 is to 3. Let's do the next sum. Sum number 30. This also has two options. Option A, the probability distribution for the number of students being absent in a class on a Saturday is as follows. So X gives you the number of students absent and P of X gives the probability for that, where X is the number of students absent. First option, calculate the value of P. Second thing, calculate the mean of the number of absent students on Saturday. So let us try to solve the first sum. We know that sigma P of X equal to 1. Sum of all the probabilities is equal to 1. So that means P plus 2P plus 3P plus P should give you 1 as the answer. So when we add all of them, 1, 2, 3, 1, 3, 3, 7, 7P equal to 1 we are getting. So that gives you P equal to 1 by 7. Since we need to find the mean, we have to create the table once again using the probabilities which we found. 0, 1 by 7, 2, 2p means 2 into 1 by 7, which is 2 by 7, 4, 3p means 3 by 7, 5, 1 by 7. So second sum, we need to solve for mean. So mean equal to, by formula we know, sigma x times p of x. That is equal to 0 into 0's probability plus 2 into 2's probability plus 4 into 4's probability plus 5 into 5's probability. So the first value is 0, 2 into 2 by 7 is 4 by 7, 4 into 3 by 7 is 12 by 7, 5 into 1 by 7 is 5 by 7. So taking 7 as LCM, we have 4 plus 12 plus 5 in the numerator, which is 21 by 7, which is 3. So the mean for the absent students will be 3. Let us do the next sum. Option B. For the vacancy advertised in the newspaper, 3,000 candidates submitted their applications. From the data, it was revealed that 2/3 of the total applicants were females and the other were males. The selection for the job was done through a written test. The performance of the applicants indicates that the probability of a male getting a distinction in written test is 0.4 and that a female getting a distinction is 0.35. Find the probability that the candidate chosen at random will have a distinction in the written test. So the candidate chosen has two options, right? Suppose if I choose a person, there are two options, whether it is a male or a female. So if it is a male, what is the probability for getting a distinction? Female, then what is the probability of getting a distinction? So this sum is based on the total probability theorem. So we need to define the events accordingly and then we have to continue with the calculation. So let us define the events here. Let E1 and E2 be the events that the applicant is a male, female respectively. So E1 is the event of selecting a male candidate. E2 is the event of selecting a female candidate. Let A be the event that the candidate chosen will have a distinction in the written test. So after making the events ready, we need to find P of A, of course. So P of A will be sigma P of EI into P of A given EI. I equal to 1 to 2 only. We have only two options. Okay. Now, what is P of E1? P of E1 is the selected applicant is a male. So, 1/3 of the total candidates were males. So, it is 1 by 3. And P of E2, 2/3 of the total applicants were females. So, this is 2 by 3. And when you know that the selected candidate is a male, yeah, so E1 has already happened. So the probability that the candidate is getting a distinction in the written test, provided the person is a male, will be 0.4, and the probability that the chosen person is a female getting distinction will be 0.35. So let us calculate P of A now. P of A will be P of E1 into P of A given E1 plus P of E2 into P of A given E2. So this will be 1 by 3 into 0.4 plus 2 by 3 into 0.35. We can write this as a fraction too. So 1 by 3 into 4 by 10 plus 2 by 3 into 35 by 100. Further, we have 1 by 3 into 4 by 10 will be 4 by 30. Then 2 by 3 into 35 by 100 will be 70 divided by 300. We can cut a 0 here. So this will be 4 by 30 plus 7 by 30. Take 30 as the LCM. So we get 4 plus 7 in the numerator, which is 11 by 30. So P of A's answer is equal to 11 by 30. Let's do the next sum. Sketch the graph of y equal to modulus of x plus 3 and find the area of the region enclosed by the curve x-axis between x equal to minus 6 and x equal to 0 using integration. Let's see how to draw the graph. So the given curve is y equal to modulus of x plus 3. First of all, where will this curve touches x-axis? If you know that, you can draw this nicely, right? So in order to know where this curve touches x-axis, you set this y equal to 0, right? So 0 equal to x plus 3, that gives you x equal to minus 3. So that's how we plot this point minus 3, 0. And you know how the modulus curve looks. It will be in V shape usually. So we drew the curve like this. The area we need to find is between x equal to minus 6 and x equal to 0 in between these two values. So when we mark them, see this is minus 6 and this is 0. So the area we need to find is the green colored shaded region. And as you can see, these two are two different triangles. We need to find the area of two triangles, add them together. But here we can see something. Both the triangles have the same base and same height. Both base is 3 and height is 3 for both of them. So, since they are symmetric in shape, better find one area, one triangle's area, and we will multiply that by a 2. So, that is the concept we are going to try here. So, what is our plan is we will find the area between minus 3 and 0. So, basically we will get the area of this triangle and later we will multiply that by a 2 to get the area of the other triangle, both the triangles. So, as I told you, we are going to find the area between minus 3 and 0. So, the required area will be A equal to minus 6 to 0. Since the limits for x are given, we have to put a dx here. So, the area will be y times dx. So, we can do this like 2 times minus 3 to 0 y dx. The value of y will be x plus 3 only. Why? Because modulus of x plus 3 has two different values, as you know. It will be minus of x plus 3 when x is below minus 3. It will be just x plus 3 when x is greater than or equal to minus 3. Since we are in the second region, x greater than or equal to minus 3, our modulus value will take only x plus 3 as the value. So, we are putting like this. Now, we can split this into individual integrals like minus 3 to 0 x dx plus 2 times integral minus 3 to 0 3 dx. And continuing, we get 2 into x square divided by 2 between minus 3 to 0 plus 2 into 3 also comes out and integral dx's answer is x between minus 3 to 0. And this will be, this 2 and 2 cancels, x square between minus 3 to 0 plus 6 into x between minus 3 to 0. This will be 0 square is 0 minus of minus 3's square. This is for the first one, plus 6 into 0 minus minus 3. This will be minus 9 plus 18. So, the area is 9 square units. Let us solve section D, long answer type, 5 marks each. Sum 32 has two choices. The first one is if square root of 1 minus x square plus square root of 1 minus y square equal to a times x minus y, then prove that dy by dx equal to square root of 1 minus y square divided by 1 minus x square. Here we are going to do substitution. We are going to take x equal to some sin A and y equal to some sin B. So that's what we are starting with. Let x equal to sin A and y equal to sin B. Therefore, 1 minus x square equal to 1 minus sin square A, which is cos square A, So square root of 1 minus x square will be square root of 1 minus sin square a, which is square root of cos square a, which is cos a. Same way, square root of 1 minus y square will be square root of 1 minus sin square b, which is square root of cos square b, which is cos b. So let's see what happens if we replace our xy with the substituted values. Therefore, square root of 1 minus x square plus square root of 1 minus y square equal to a times x minus y implies square root of 1 minus x square's answer is cos a and square root of 1 minus y square's answer is cos b equal to a times x will be sin a minus y will be sin b. Now also we can solve this, apply identities further. So cos a plus cos b will be 2 cos a plus b by 2 into cos a minus b by 2, isn't it? So we can write like that, 2 cos a plus b by 2 into cos a minus b by 2 equal to a into sin a minus sin b will be 2 cos a plus b by 2 into sin a minus b by 2. Now this becomes 2 cos a plus b by 2 into cos a minus b by 2 equal to 2a cos of a plus b by 2 into sin of a minus b by 2. And as you can see, 2 cancels on both sides and cos of a plus b by 2 cancels on both sides. So the remaining items are cos of a minus b by 2 equal to a times sin of a minus b by 2. This can be simplified further. We can write this like cos of a minus b by 2. This sin of a minus b by 2 we can bring to the other side. Sin of a minus b by 2 equal to small a, and cos by sin of the same angle will be cot of the angle. So cot of a minus b by 2 equal to a. Now we can apply cot inverse on both sides. So we get cot inverse of cot of a minus b by 2 equal to cot inverse a. This side cot inverse and cot will cancel each other. So we get a minus b by 2 equal to cot inverse a. And taking this denominator 2 to the other side, we have a minus b equal to 2 cot inverse a. Since we have simplified this much, now we are going to replace the values of a and b. What are the values of a and b? When we apply sin inverse on both sides, we get sin inverse of x equal to sin inverse of sin a, which is a. So a's value is sin inverse of x and b's value is sin inverse of y similarly. So let's see how to differentiate hereafter. So that implies sin inverse x minus sin inverse y equal to 2 times cot inverse of a. Now differentiation will be very easy. Differentiating with respect to x, we will have 1 divided by root of 1 minus x square, because you guys know that d by dx of sin inverse x will be 1 by root of 1 minus x square, and d by dx of sin inverse y will be 1 by root of 1 minus y square, but we are differentiating with respect to x. So applying chain rule, we have into dy by dx. So this will be like 1 by root of 1 minus y square into dy by dx equal to 2 is a constant, small a is a constant. So cot inverse of small a is also constant. So all are constants in the right side. So differentiation will be 0. Now we need to simplify this. So 1 by root of 1 minus y square into dy by dx with a negative sign equal to negative 1 by root of 1 minus x square. Both the negative signs will cancel. So dy by dx will be this root of 1 minus y square goes to the numerator of the other side divided by square root of 1 minus x square. And that's what we need to prove here. Now let us move on to the next part. 32b. If x equal to a times cos theta plus log tan theta by 2 and y equal to sin theta, then find d square y by dx square at theta equal to pi by 4. So the idea here is x is dependent on theta. So theta is the variable, and here also y is also dependent on theta. So we can only find dx by d theta and dy by d theta. So this is the parametric representation. So we know dy by dx is equal to dy by d theta divided by dx by d theta, and d square y by dx square will be d by d theta of dy by dx into d theta by dx. First of all, let us find out dx by d theta. So taking x equal to a into cos theta plus log tan theta by 2 dx by d theta equal to a is a constant, it will stay as it is, and the differentiation for cos theta will be minus sin theta plus log of tan theta by 2. First we will give priority to log, so its differentiation will be 1 by tan theta by 2, and applying chain rule, tan theta by 2 has to be differentiated again. Differentiation of tan will be secant square, so it is secant square theta by 2, and theta by 2 has to be differentiated again, which will give you 1 by 2. Now we need to simplify this. So this will be a into minus sin theta plus, all of these are together as one term, right? So now we can convert this in terms of cos and sin. So first 1 by tan theta by 2 is cot theta by 2 into secant square theta by 2 into 1 by 2. So this will be minus sin theta plus cot theta by 2 can be written like cos theta by 2 by sin theta by 2, and secant square can be written like 1 by cos square theta by 2. This 1 by 2 is a separate term, and this will be a times minus sin theta plus 1 of the cos theta by 2's will cancel here. So we have 1 divided by 2 sin theta by 2 cos theta by 2. This 1 by 2 we are bringing to the first. 1 by 2 sin theta by 2 cos theta by 2, and we know one formula for sin 2 theta, which is 2 sin theta cos theta. So by half angle formula, 2 sin theta by 2 cos theta by 2 will be the answer for sin theta. So this will become a into minus sin theta plus 1 by sin 2 times theta by 2 will be just a theta. So now we need to take LCM as sin theta. This will be minus sin square theta, and that plus 1 will be the same, and this becomes 1 minus sin square theta, right? So 1 minus sin square theta is cos square theta. So a times cos square theta by sin theta, and this we can write like a into cos theta by sin theta into cos theta. So this will give you a cos theta by sin theta is cot theta, and that other cos theta will be the same. So this is the final answer for our dx by d theta. Now we need to find out dy by d theta. So y is given like sin theta, very simple only. So dy by d theta will be cos theta. So first let us find out dy by dx. So dy by dx equal to dy by d theta divided by dx by d theta, which is cos theta divided by a cot theta cos theta. That's the purpose we wrote dx by d theta in this weird way, so that cos theta gets cancelled. So final value for dy by dx is equal to 1 by a cot theta, and this also we are going to simplify. 1 by a times 1 by cot theta, which is 1 by a tan theta, or tan theta divided by a. So that's our dy by dx. Now we need to differentiate once again with respect to x. So again d square y by dx square equal to d by d theta only we can do for dy by dx, right? So what we are going to do is d by d theta of dy by dx into d theta by dx we will do. So d by d theta of dy by dx will be d by d theta of tan theta by a into d theta by dx means we have to reciprocate our dx by d theta and write it here. That will be 1 by a cot theta cos theta. And continuing further, 1 by a is a constant, and d by d theta of tan theta will be secant square theta into 1 by a cot theta into cos theta. And this will be 1 by a into 1 by a, that will be 1 by a square, and this is secant square theta, and 1 by cot can be written like tan theta, and 1 by cos can be written like secant theta. So the final answer is 1 by a square, secant square into secant is secant cube theta into tan theta. That's our second derivative. But we need to find out d square y by dx square when theta is pi by 4. So d square y by dx square at theta equal to pi by 4 will be equal to 1 by a square secant pi by 4 power 3 into tan pi by 4. And we know that secant pi by 4 is secant 45. Secant 45's value is root 2. So this will be 1 by a square into root 2 to the power 3, and tan 45 is 1. So this will be root 2 cube by a square, or we can write it like 2 root 2 divided by a square, because root 2 cube equal to 2 root 2. The final answer. Now let us move on to the next sum. Find the absolute maximum and absolute minimum of the function f of x equal to 2x cube minus 15x square plus 36x plus 1 on the closed interval 1, 5. So finding the maxima minima in the domain of f of x is a different thing, but when the interval is given, finding the maxima minima in the given interval is different. So what will we do is we will find the critical points of the function f of x, and after finding the critical points we will see f of critical point number 1 and f of critical point number 2 and f of 1 the end points. Okay, f of x at the end points of the given interval 1, 5. So f of 1 and then f of 5, and then among the 4 values whichever is our minimum value, we will keep that as our minimum, absolute minimum, and which one is the maximum, we will keep that value as our absolute maximum. That's the procedure. Hope you remember. So let us try to find out the critical points of the given function, for which we need to differentiate the given function. So f of x equal to 2x cube minus 15x square plus 36x plus 1. So f dash of x will be 2 into 3x square minus 15 into 2x plus 36 into 1, and 1's derivative is 0. The final value is 6x square minus 30x plus 36. That's our f dash of x, and we have to set it equal to 0. So let f dash of x equal to 0. That implies 6x square minus 30x plus 36 equal to 0. So we can divide completely by 6. Dividing by 6 we get x square minus 5x plus 6 equal to 0. And we need to factorize this quadratic function. Product of the factors is 6 and sum of the factors is minus 5. So the factors are minus 2 and minus 3, isn't it? So x square minus 2x minus 3x plus 6 equal to 0. So grouping them, we have x into x minus 2 minus 3 into x minus 2 equal to 0. And that implies x minus 2 into x minus 3 equal to 0. That implies either x minus 2 is 0 or x minus 3 is 0. That gives x equal to 2 or x equal to 3. So these are the critical points, right? So now we need to find out f of 2, f of 3 as well as f of 1 and f of 5, and we have to decide which one is the maximum and minimum. So let's try to find out our f of 2. F of 2 will be 2 into, replacing x with a 2 everywhere, we get 2 into 2 power 3 minus 15 into 2 power 2 plus 36 into 2 plus 1. This will be 2 times 8 minus 15 times 4 plus 36 times 2 plus 1. This will be 16 minus 60 plus 72 plus 1, and the final value for this will be 29. And finding f of 3, 2 into 3 power 3 minus 15 into 3 square plus 36 into 3 plus 1. This will give you 2 into 27 minus 15 into 9 plus 36 into 3 plus 1. This will give you 54 minus 135 plus 108 plus 1, and this will give 28 as the final answer. Now continuing further, we need to find out f of 1. F of 1 will be 2 into 1 power 3 minus 15 into 1 power 2 plus 36 into 1 plus 1. This will be 2 minus 15 plus 36 plus 1. This will give 24 as the answer. And f of 5 will be 2 into 5 power 3 minus 15 into 5 square plus 36 into 5 plus 1. And this will be 2 into 125 minus 15 into 25 plus 36 into 5 plus 1. And this will be 250 minus 25 into 15 will be 250 minus 375 plus 180 plus 1, and this will give you 56 as the answer. So let us list down the values we got. We got f of 1 equal to 24 and f of 2 equal to 29 and f of 3 equal to 28 and f of 5 equal to 56. So 24 is the minimum value among all. So that will be our absolute minimum. And 56 is the maximum amongst all. So 56 will be our absolute maximum. That's the conclusion. Let's move on to the next sum. Find the image A dash of the point A163 in the line x by 1 equal to y minus 1 by 2 equal to z minus 2 by 3. Also find the equation of the line joining A and A dash. So when we draw the given scenario, this is the line and here is our point A and here is our point A dash. We can connect A and A dash. Let this point on the line where A dash meets is our point M. Now one thing we have to be clear about is, see, the point is 163 and A dash we don't know. Let us call this like alpha, beta, gamma. One thing we have to be clear about is, so the distance between the object and the mirror and the image, they should be equal to each other. So MA and MA dash should be equal to each other. That means M is the midpoint of A dash. So we have to keep this in mind before solving the sum. First of all, we need to find the coordinates of the point M generally. Okay, so for that we will take the given line x by 1 equal to y minus 1 by 2 equal to z minus 2 by 3. Since there is no point given with x, we can rewrite this like x minus 0 divided by 1 because x minus 0 is x only. Y minus 1 by 2 equal to z minus 2 by 3 equal to some lambda, for example. Okay, so here we can compare each of these fractions with lambda. So x minus 0 by 1 equal to lambda implies x minus 0 equal to lambda, that implies x equal to lambda, and y minus 1 by 2 equal to lambda implies y minus 1 equal to 2 lambda and y equal to 2 lambda plus 1. Same way, z minus 2 divided by 3 equal to lambda implies z minus 2 equal to 3 lambda and z equal to 3 lambda plus 2. So, let M be any arbitrary point on the given line. Therefore, M will be, M's x value will be lambda and y value will be 2 lambda plus 1, z value will be 3 lambda plus 2. So M will be lambda 2 lambda plus 1, 3 lambda plus 2. Now we need to find the DRs of the segment AM. So the direction ratios of AM are, how do we find it? M's value minus A's value, right? So lambda, first value of M, lambda, first value of A is 1, so lambda minus 1. And the second one is 2 lambda plus 1 minus 6 and 3 lambda plus 2 minus 3. That is, we can simplify lambda minus 1, 2 lambda plus 1 minus 6 is 2 lambda minus 5 and 3 lambda plus 2 minus 3 is 3 lambda minus 1. So these are the DRs of AM segment. What we can say here is AM is perpendicular to the given line. So we are going to do dot product of the DRs equal to 0. So the lines DRs are already here. The ones in the denominators of xy, that value, right? Those are the DRs of the given line. So 1, 2, 3 are the DRs of the given line. We already know that. So DRs of given line are 1, 2, 3. Since AM perpendicular to the given line, dot product of the DRs equal to 0. So let us find the dot product of the DRs. So AM's DRs are lambda minus 1, comma 2 lambda minus 5, comma 3 lambda minus 1 dot 1 comma 2 comma 3. This should be equal to 0. So that implies lambda minus 1 into 1 plus 2 lambda minus 5 into 2 plus 3 lambda minus 1 into 3 equal to 0. That's how we take the dot products, right? So that will be lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3 equal to 0. That implies 1 lambda, 4 lambda and 9 lambda. Their total is 14 lambda. Minus 1, minus 10, minus 3 will be minus 14 equal to 0. That implies 14 lambda equal to 14. That implies lambda equal to 1. Since we got to know lambda's value, we can rewrite the coefficients of m. So therefore m is lambda 2 lambda plus 1 and 3 lambda plus 2, isn't it? That is replacing lambda with 1 now. M is 1. 2 into 1 plus 1 is 2 plus 1 3. 3 into 1 plus 2 is 3 plus 2 5. So m's coordinates are 1 3 5 now. But as I told you, a dash is perpendicular to the line as well as m is the midpoint of a dash. So midpoint of a dash equal to m. That implies midpoint of a dash will be, a's coordinates are 1 6 3. For our remembrance, we will write it here. A is 1 6 3 and a dash is alpha beta gamma. That's how we have named them. So midpoint of a dash will be 1 plus alpha by 2 comma 6 plus beta by 2 comma 3 plus gamma by 2 equal to m's values are 1 3 5. So we have to equate the corresponding coefficients. So we get 1 plus alpha by 2 equal to 1 and 6 plus beta by 2 equal to 3 and 3 plus gamma by 2 equal to 5. That implies alpha plus 1 equal to 2, alpha equal to 2 minus 1, 1. 6 plus beta equal to 6. So beta equal to 6 minus 6, 0. And 3 plus gamma equal to 10. So gamma equal to 10 minus 3, 7. Therefore, a dash is alpha beta gamma, that will be 1 0 7. So the image of a on the given line will be the point 107. And we are not yet done. We need to find the equation of the line a dash also. So we know that when 2 points are given, the equation of the line passing through the 2 points will be the equation of a dash is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. And a dash is 107 and a is 163. So let this be our x1 y1 z1. Let this be our x2 y2 z2. So equation of a dash is x minus 1 divided by 1 minus 1 equal to y minus 6 divided by 0 minus 6 equal to z minus 3 divided by 7 minus 3. That is, the equation is x minus 1 by 0 equal to y minus 6 by minus 6 equal to z minus 3 divided by 4. But we can't have any common factor for the drs, right? So, drs of this particular line will be 0, minus 6 and 4. Minus 6 and 4 are having 2 as a common factor, which is not allowed. So, we better divide the full drs by a 2. So, we can write this line's equation like x minus x1 by 0 equal to y minus 6 divided by minus 3, because we are dividing by a 2, equal to z minus 3 divided by 2. That's the required equation. Let's move on to the next sum. Find a point P on the line x plus 5 by 1 equal to y plus 3 by 4 equal to z minus 6 by minus 9, such that its distance from point Q is 7 units. Also find the equation of line joining P and Q. Let's try to understand the situation by drawing this. Let this be the given line. This be the point P on the line, and let this be the point Q given, which is 2, 4, minus 1, and the distance between P and Q is given to be 7 units. Now we need to find out the coordinates of P here, and we have to find the equation of the line joining P and Q. So let's try to find out the point P first. Same way as we have done in the previous sum, let us take the line's equation given x plus 5 by 1 equal to y plus 3 by 4 equal to z minus 6 by minus 9. Let this be equal to lambda, say. That implies x plus 5 by 1 equal to lambda. That implies x plus 5 equal to lambda, x equal to lambda minus 5. And y plus 3 by 4 equal to lambda. That implies y plus 3 equal to 4 lambda, y equal to 4 lambda minus 3. And z minus 6 by minus 9 equal to lambda. That implies z minus 6 equal to minus 9 lambda, and z equal to minus 9 lambda plus 6, or we can write this like 6 minus 9 lambda. So, any arbitrary point on the given line will be of the form x, y, z, correct? Lambda minus 5, 4 lambda minus 3, 6 minus 9 lambda. Therefore, P is also the same way, same form. Lambda minus 5, 4 lambda minus 3, 6 minus 9 lambda. Now we know P's value, and the next hint given is distance between P and Q is 7 units. So let us discuss about that. PQ equal to 7 units. So we need to find the distance between P and Q. That implies square root of lambda minus 5 minus 2 whole square plus 4 lambda minus 3 minus 4 whole square plus 6 minus 9 lambda minus of minus 1 will be plus 1 whole square will be 7. That implies square root of lambda minus 7 whole square plus 4 lambda minus 7 whole square plus 7 minus 9 lambda whole square equal to 7. Now we can square on both sides to get rid of the square root. That will give you lambda minus 7 whole square plus 4 lambda minus 7 whole square plus 7 minus 9 lambda whole square equal to 7 square, which is 49. Let's continue. That implies we can expand each of the squares using identities. Lambda minus 7 whole square will be lambda square minus 2 into lambda into 7, which is 14 lambda, plus 7 square is 49. And the second one is 4 lambda minus 7 whole square. That will be 4 lambda whole power 2, which is 16 lambda square, minus 2 into 4 lambda into 7. That will be 28 into 2, 56 lambda, plus 7 square, which is again 49. And then plus 7 minus 9 lambda whole square will be 7 square, which is 49, minus 2 into 9 lambda into 7, that is 9 7s are 63, 63 into 2 will be 126. So 126 lambda, and 9 lambda's square will be 81 lambda square. The other side we have 49, remember? So let us remove the brackets and simplify them. Lambda square plus 16 lambda square plus 81 lambda square minus 14 lambda minus 56 lambda minus 126 lambda plus 49 plus 49 plus 49. All are 49s here. Minus 49 equal to 0. So these two 49s will cancel and we get lambda square plus 16 lambda square plus 81 lambda square will be 88 lambda square, and minus 14 lambda minus 56 lambda minus 126 lambda, when we add them we get minus 196 lambda plus 49 plus 49 is 98 equal to 0. So here we can take 98 common outside. This will give you 98 into lambda square minus 98 2s are 196. So 2 lambda plus 1 equal to 0. That will imply lambda square minus 2 lambda plus 1 equal to 0, isn't it? 98 can't be 0. So this will give you the factorization for lambda square minus 2 lambda plus 1, which is product of the factors is 1 and sum of the factors is minus 2. So both the factors are negative 1. So that will be lambda square minus lambda plus 1 equal to 0. So taking lambda common from first two terms, we get lambda into lambda minus 1. And taking minus 1 out of the next two terms, we get minus 1 into lambda minus 1. So this gives you lambda minus 1 into lambda minus 1 equal to 0. So that makes sure we are getting lambda equal to 1 in both the cases. So now we know lambda's value, so we can rewrite our p's value. So what was our p? P was originally lambda minus 5, 4 lambda minus 3 and 6 minus 9 lambda. Now we can put the value of lambda here. P of 1 minus 5 is minus 4. 4 into 1 4, 4 minus 3 is 1, 6 minus 9 will be minus 3. So point P is minus 4, 1, minus 3. They are asking for the equation of the line passing through PQ also. So point P is minus 4, 1, minus 3 and point Q is 2, 4, minus 1. So we can take one of the points like x1, y1, z1, next point like x2, y2, z2. So equation of line PQ is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. That is x minus of minus 4 is x plus 4 by 2 plus 4 equal to y minus 1 by 4 minus 1 equal to z minus of minus 3 is z plus 3 by minus 1 minus of minus 3 is plus 3. That is x plus 4 by 6 equal to y minus 1 by 3 equal to z plus 3 by 2. So 6, 3 and 2 don't have any common factor. So we can leave this way. This is the required equation of line PQ. Let's move on to the next sum. Sum number 35. A school wants to allocate students into 3 clubs, sports, music and drama under following conditions. The number of students in sports club should be equal to the sum of the number of students in music and drama club. The number of students in music club should be 20 more than half the number of students in sports club. The total number of students to be allocated in all the 3 clubs are 180. Find the number of students allocated to different clubs using matrix method. First of all, we need to create 3 linear equations using the 3 given conditions, for which we need to assign the variables. So, let x, y and z be the number of students allocated to sports club, music club and drama clubs respectively. So let us try to impose the given conditions into our variables. Number of students in sports club, that is x, should be equal to sum of the number of students in music and drama. Sum of the numbers means y plus z. So according to the first condition, x equal to y plus z. So we can rewrite this like x minus y minus z equal to 0. That will be our first equation. Now seeing the second condition, the number of students in music club, I mean y, should be 20 more than half the number of students in sports club, I mean x. So half the number of students in sports club is x by 2, 20 more than x by 2. So x by 2 plus 20. So y should be equal to x by 2 plus 20. And we have to rewrite this also. Y minus x by 2 equal to 20. We can multiply by a 2 throughout. So we get 2y minus x equal to 40. Or we can write this like minus x plus 2y equal to 40. We can multiply throughout with a negative sign so that we get x minus 2y equal to minus 40. And this is our second equation. Now imposing our third condition on the variables. The total number of students to be allocated in all the 3 clubs, I mean x, y, z, all their total should be 180. So x plus y plus z is equal to 180. That's our third equation. So you guys know that when we are going to solve the linear equations using matrix method, we have to write in this way. Given equations may be written as matrix A into matrix X equal to matrix B, where A is the coefficient matrix, we call it. So we will take the coefficients of x, y and z in all the 3 equations in the correct order. First value should be always x, second value should be always y, third value will be always z. So from the first equation, the coefficients are 1 minus 1 minus 1, and from the second equation the coefficients are 1 minus 2 and there is no z, so put a 0. And from the third equation, the coefficients are 1, 1, 1. So that's our coefficient matrix. And x is the variable matrix. We call this like x, y, z. And b is the solution matrix. I mean the right hand side of the three equations that are 0, minus 40 and 180. So after doing so, we have to make sure that determinant of A is not equal to 0, otherwise A inverse does not exist, right? So let us find the determinant of the matrix A, which is determinant of 1 minus 1 minus 1, 1 minus 2 0, 1 1 1. This will be 1 into minus 2 minus 0. Minus of minus 1 will become plus 1 into 1 into 1 1 minus 1 into 0 0. Then plus of minus 1 is minus 1 and its minor is 1. Minus of minus 2 will be plus 2. This will be 1 into minus 2 plus 1 into 1 minus 1 into 3. That is minus 2 plus 1 minus 3, which is minus 5 plus 1 minus 4. So determinant of A is minus 4, which is non-zero. So we have confirmed that. Now let us continue with the rest of the things. So Ax equal to B implies when we multiply by A inverse on both sides, we have A inverse into Ax equal to A inverse into B. That implies A inverse A into x because multiplication is associative. So this will give you I matrix, right? A inverse into A is identity matrix. So I into x will be x only. So x equal to A inverse times B. So if we find A inverse, B we already have. We can multiply both of them. That is our required answer. So we need to find out A inverse, for which we need to find out the adjoint matrix of A first, because A inverse will be 1 by determinant of A into adjoint matrix of A, right? So we need to find out adjoint matrix of A first. So adjoint matrix of A will be, let us do the minor matrices of all the values. For your reference, I am writing the A matrix here. 1 minus 1 minus 1, 1 minus 2 0, 1 1 1. This is the original A matrix. Now adjoint matrix of A will be, first we have to find the minor of row 1 column 1, I mean this one. That will be the minor minus 2 0 1 1. Its sign is positive. And then next element is minus 1, and minus 1's minor will be 1 0 1 1. That should be given a minus sign. And minus 1's minor is going to get a plus sign, which is 1 minus 2 1 1. And let's go to the second row. The minor of second row first column entry, this guy, will be the minor having minus sign, which is minus 1 minus 1 1 1. And the minor of this entry will be having a plus sign, and the entries inside this will be 1 minus 1 1 1. And the minor of this entry will be having a minus sign, and the minor will be 1 minus 1 1 1. And the third row first column entry, this guy's minor will be having a plus sign, which is minus 1 minus 1 minus 2 0. And the third row second column, this guy's minor will be having a minus sign, and that will be 1 minus 1 1 0, and the third entry's minor will be plus sign. It will be 1 minus 1 1 minus 2. So this we have to solve, then only we will be able to find out our RGA's value, and that is going to be our RGA will be minus 2 minus 0, which is minus 2, and the determinant's answer is 1 minus 0. There is a minus outside, so that will be minus 1, and the third determinant will be, this guy's transpose actually we have to take, right? So minus 1, and this will be 1 plus 2 3, and the second row will be minus 1 minus of minus 1 will be minus 1 plus 1. So 0 minus 0 is also 0 only, and this is 1 minus of minus 1, so 1 plus 1 2, and the next one is 1 plus 1 2, there is a minus outside, it will be minus 2, and the third row first entry will be 0 minus 2, which is minus 2, and the second entry will be 0 plus 1 1, there is a minus outside, so minus 1, and this entry will be minus 2 plus 1, so that will be minus 1. This guy's transpose we need. So RGA will be, changing the columns as rows and rows as columns, we have minus 2 minus 1 3, and 0 2 minus 2, and minus 2 minus 1 minus 1. So that is our adjoint matrix of A. Now we need to find the value of A inverse. So A inverse will be 1 by determinant of A into adjoint matrix of A. That will be 1 by minus 4 into this matrix, minus 2 0 minus 2, minus 1 2 minus 1, 3 minus 2 minus 1. Now we need to find out the value of x. So x equal to A inverse into B, which is, write A inverse as it is, minus 1 by 4 into minus 2 0 minus 2, minus 1 2 minus 1, 3 minus 2 minus 1, and B matrix is 0 minus 40 180. We can multiply these two, minus 1 by 4 and the other matrix. So we keep this A inverse matrix as it is right now, minus 2 0 minus 2, minus 1 2 minus 1, 3 minus 2 minus 1 into minus 1 by 4 into 0 is 0, minus 1 by 4 into minus 40 will be plus 40 by 4, which is 10, and minus 1 by 4 into 180 will be minus 180 by 4, minus 180 by 4, which is minus 45. Now we need to multiply both these matrices, and this will give you minus 2 into 0 plus 0 into 10 plus minus 2 into minus 45. That's the first row, first entry. Then minus 1 into 0 plus 2 into 10 plus minus 1 into minus 45. That's the second entry. And 3 into 0 plus minus 2 into 10 plus minus 1 into minus 45. And the first entry will give you 0 plus 0 plus 90, so 90. Then second entry will give you 0 plus 20 plus 45. So 20 plus 45 will be 65. And the next entry will be 0 minus 20 plus 45. Minus 20 plus 45 will be plus 25. So that implies x value will be, our x matrix was x, y, z, right? So the first entry was the answer for x. So x equal to 90 and y equal to 65 and z equal to 25. So the number of students allocated in sports club were 90, and number of students allocated in music club were 65, and the number of students allocated to the drama club were 25. So that's the answer. Let's solve section E, case study based questions carrying 4 marks each. Sum number 36. Let's read the question. A technical company is designing a rectangular solar panel installation on a roof using 300 meters of boundary material. The design includes a partition running parallel to one of the sides, dividing the area into 2 sections. Let the length of the side perpendicular to the partition be x meters and with parallel to the partition be y meters. So let's try to understand this sum. First of all, this is one solar panel which is going to be installed in a roof. The boundary material is having 300 meters length. So what do you mean by the boundary material? So this one and this one and this one and this one and this one. See, there is a partition here that also should be considered. So all of these we have to use 300 meters of available material to construct this. Then they are giving the side values also as variables. So they are saying the length of the side perpendicular to the partition be x meters. So this is the partition. So the perpendicular lengths are this one and this one. These are considered like x. So this is x and this is also x. And the sides which are parallel to the partition, I mean these two are the parallel things. So if this is y, this is also y. That's what is given. Now we need to use this information to answer the following questions. Based on this information, answer the following questions. Write the equation for the total boundary material used in the boundary and parallel to the partition in terms of x and y. For you to understand better, I am drawing that solar panel in a miniature size. This is how it is, right? So here is the partition. So the sides which are parallel to the partition are called y. So this is y and this is also y. And these two sides, the other two sides are called x. So all are in meters only. So this also to be considered because the material will be used in all the lines. Wherever the lines are coming, the materials will be used there. So first we have to create the equation for the given information. So what we can say is the total available material is 300 meters. So sum of all these panel lengths should be equal to 300 meters. For example, if we add all of them, x plus y plus x plus y plus y, that should be equal to 300 meters. Or else we can write it like 2x plus 3y equal to 300. So this is the required equation for the total boundary material used in the panels. Now let us solve the next sum. Write the area of the solar panel as a function of x. You know that this is one rectangle, right? So area of the panel means the top surface's area, length into breadth only. So area will be length is x and breadth is y. So that is the area required. But from the previous written equation, we have 2x plus 3y equal to 300. From there, we have to convert the y value in terms of x because they are asking the area just as a function of x. So we have to convert this. So 3y will be equal to 300 minus 2x. So y will be 300 minus 2x divided by 3. So that value of y we will use here. So this is like x into 300 minus 2x divided by 3. That is 1 by 3 times x into 300 minus 2x. That can be written like 1 by 3 into 300x minus 2x square, applying distributive property inside the brackets. So that's the final value for the area as a function of x. Let's move on to the next sum. It has two choices. Part A is find the critical points of the area function. Use second derivative test to determine critical points at the maximum area. Also find the maximum area. So the area function, whichever we have found and kept in the previous part, we are going to make use of that, which is 1 by 3 into 300x minus 2x square, and we have to use the second derivative test. So we have to find the first derivative and second derivative, and we will find the critical points using the first derivative, setting it equal to 0, and whatever points we have obtained from that, we will put that in our second derivative, and we will check whether the second derivative is greater than 0 or less than 0. If the second derivative is greater than 0, then the obtained critical point will be a minimum point. If the second derivative is less than 0, then the obtained critical point will be a maximum point. Correct? So that's what we are going to do here. So first thing we are going to do is the first derivative, dA by dx. So 1 by 3 is a constant which is in product, so don't disturb it. Let it be. So 300x's derivative is 300 into 1 minus 2x square's derivative is 2 into 2x. So this is 1 by 3 into 300 minus 4x. And let's find the second derivative, d square a by dx square equal to 1 by 3 is still a constant. 300's derivative is 0 minus 4x's derivative is 4 into 1. 1 by 3 into minus 4, which is minus 4 by 3. Now setting dA by dx equal to 0, we get 1 by 3 into 300 minus 4x equal to 0. That gives you 300 minus 4x equal to 0, because 1 by 3 is non-zero. That will give you 300 equal to 4x, x equal to 300 by 4, which is 75. So d square a by dx square at x equal to 75 will be still minus 4 by 3 only, because there is no variable in that, which is a less than 0 quantity. That implies x equal to 75 is a maximum value. Therefore, area will be maximum when x equal to 75 meters. And also, they are asking for the maximum area of the solar panel. So, maximum area will be equal to 1 by 3 into 300 into 75 minus 2 times 75 square, by putting x equal to 75 in the value of area. So this will give you will get 3750 meter square. That is the required maximum area. Let's move on to the next choice of this question. Part B. Using first derivative test, calculate the maximum area the company can enclose with the 300 meters of boundary material, considering the parallel partition. So this is also same only, but one thing we have to understand is we have to apply the first derivative test. So hope you know how to do the first derivative test for maxima minima. We have to find f dash of x and we have to set it equal to 0, and we will find the critical points. Up until that part everything is the same. After finding that, whatever critical point we are getting, we have to take the neighborhood of the critical point. What do you mean by neighborhood? Suppose if C is the critical point, we have to consider a small interval which contains C in the middle, and you have to try the value of f dash of x in both the ends. So that will tell you whether the function was increasing or decreasing on both the ends. For example, if f dash of x is greater than 0, then the function will be increasing in that zone. And when f dash of x is less than 0, then the function will be decreasing in that zone. So depending on that, we can decide what type of point the critical point was, and that will conclude the result. F dash of x will be the same as we have done in the previous part. I mean dA by dx. So it is 1 by 3 into 300 minus 4x. So we will take the same here. So dA by dx equal to 1 by 3 into 300 minus 4x. The same way we have to set it equal to 0. That implies 1 by 3 into 300 minus 4x equal to 0. This also will give you x equal to 75 as the answer. Since we have already done this, I am skipping that part. So x equal to 75 is the only obtained critical point. So now consider 75's neighborhood. So you can consider 74 to 76 as an interval and check the nature of f dash of x in that interval. So for example, dA by dx value when x equal to 74 will be 1 by 3 into 300 minus 4 times 74, right? So that will be equal to 1 by 3 into 300 minus 296. That will be 1 by 3 into 4, which is 4 by 3 greater than 0. So f dash is greater than 0. I mean the function is increasing in the left side of 75. Correct? Now let us check the nature on the right side of 75. So for that, let us take dA by dx value when x equal to 76. So that will be 1 by 3 into 300 minus 4 into 76. So that will be 1 by 3 into 300 minus 304. That will be minus 4 by 3, which is less than 0. So what we can say is the area function is increasing on the left side of 75 and decreasing on the right side of 75. So the curve should be something like that, increasing like this and decreasing. So the point, the peak point obtained when this happens at the point 75 will give you 75 as a maximum point. So therefore you have to write like that, dA by dx changes its sign from positive to negative as x passes through x equal to 75 from left to right. That implies x equal to 75 is a maximum point. So maximum area, here also we have to find the maximum area. Same area only, maximum area is will be 1 by 3 into 300 into 75 minus 2 into 75 square. That will give you the same 3750 meter square as the answer. That's the end of our first case study. Now let us go to the second one. A classroom teacher is keen to assess the learning of her students, the concept of relations taught to them. She writes the following 5 relations, each defined on the set A equal to 1, 2, 3. The first relation R1 is 2, 3, 3, 2. And the relation R2 is 1, 2, 1, 3 and 3, 2. And R3 is 1, 2, 2, 1, 1, 1. And R4 is 1, 1, 1, 2, 3, 3, 2, 2. And R5 is 1, 1, 1, 2, 3, 3, 2, 2, 2, 1, 2, 3, 3, 2. The students are asked to answer the following questions about the above relations. Let us move on to the first sum. Identify the relation which is reflexive, transitive but not symmetric. So first of all, let's understand something. Our set A equal to 1, 2, 3. So when will we accept the relation as a reflexive relation? Small a comma a belong to our relation for every a in capital A. Since capital A contains 3 elements, we should have 1 comma 1, 2 comma 2, 3 comma 3 available in our relation R. Whichever relation satisfies this condition can be considered reflexive, isn't it? So in that aspect, if you see, R1 don't even satisfy this condition, and R2 also is not satisfying, and R3 is also not satisfying. R4 1 1 2 2 3 3, it is having all the 3 items required. So R4 is reflexive, and R5 also 1 1 2 2 3 3 all are available. So R5 also satisfies reflexive property. Then transitive property. So what do you mean by transitive property? When A comma B is in R and B comma C is in R, both should give you A comma C available in R. So whichever relation obeys this condition can be considered transitive. So thinking that way, if you see here, want to have a relation which satisfies reflexive as well as transitive. Since the R1, R2, R3 were already failing to prove there is a reflexive relation, we can't check the transitive property with them. Only R4 and R5 are our concern now. Let us check which of these are satisfying the transitive property. Suppose if we take any two, okay, this entry and this entry should be the same, right? Suppose if I take 1 1 and 1 2 from R4, their combination should give me this last and this last 1 comma 2 again, which is already there. And if I take 1 2 and 2 2, 1 2 and 2 2, I have this first and that last, which is 1 2 again. I already have it. So we don't have any other entry which is having A comma B and B comma C. So the second element of the first ordered pair and the first element of the second ordered pair should be matching. So that way we only have 2 pairs. Both of them are having the third item included in the same set. So we can say R4 is obeying transitive property as well. Now let us think about R5. 1 1 1 2 is there. Their combination will give you 1 2 again. So that is okay. And then 2 2 2 1. If I take this pair for R5, 2 2 2 1. So this second entry and this first entry are same. So if we combine them, again this is giving us 2 1, which is already there. And then if I take 2 1 and 1 2, 2 2 will be obtained. That is also there. If I take 2 3 and 3, it is also giving me 2 3 as the answer. That is okay. If I take 2 3 and 3 2, that is giving me 2 2. That is also okay. So when I take 1 2 and 2 1, I am getting back 1 1. So when I take 1 2 and 2 3, there is the problem. Okay. Suppose if I take 1 comma 2 and 2 comma 3 from R5, which are here, their combination, the second entry and first entry are same. Their combination should give me 1 comma 3, but R5 is not having 1 comma 3, so I can't accept R5 is obeying transitive property. So only reflexive property is obeyed in R5, not the transitive property. So who is satisfying both the properties? Only R4. So that is the answer for our 37 part 1. So R4 obeys both reflexive transitive properties. So we have to tell them how it is obeyed. Okay, so that is A comma A belongs to R4 for all A belong to capital A. That is the definition for reflexive property. And A comma B comma C belong to R4 implies A comma C belong to R4 for all A, B, C taken from capital A. And transitive property and symmetric property is not obeyed, that we have to prove there. So if you look at your R4, 1 comma 2 is there, but 2 comma 1 is not there. So symmetric property is not obeyed in R4. So that we have to tell here. Also in R4, 1 comma 2 belong to R4, but 2 comma 1 does not belong to R4. Therefore R4 is not symmetric. Therefore R4 is the only relation which is obeying reflexive and transitive but not symmetric property. So that's the end of our first subdivision. Let's move on to the second one. Identify the relation which is reflexive and symmetric but not transitive. That is our R5. Let's see how. We have already seen that R5 obeys reflexive property. That is completely understood. And now if you see symmetric property, 2 comma 1 is there and 1 comma 2 is also there. If you take 2 comma 3 here, 3 comma 2 is also there. 2 comma 1, 1 comma 2. And all other entries are self-reflexive, right? So that means every entry has the mirrored ordered pair also. So we can say R5 obeys symmetric property, but we already have checked that R5 is not obeying transitive property. When we had 1 comma 2 and 2 comma 3, we did not had 1 comma 3 in there. So that we already have found out. Now we have to just answer and conclude it. Okay, so answer is R5. Okay, R5 is reflexive and symmetric. How do you know that? You have to mention that is every A comma A belongs to R5 for every A in capital A. Also symmetric property, A comma B belong to R5 implied B comma A also belong to R5 for every A and B taken from the set A. So this is enough for reflexive and symmetric proof. But why transitive property is not obeyed, we have to give the reason. So also in R5, 1 comma 2 comma 2 comma 3 belong to R5, but 1 comma 3 does not belong to R5. Therefore R5 is not transitive. So that is the proof we wanted to give. So R5 is the required relation which is reflexive and symmetric but not transitive. Let's move on to the next sum. So this has choices. The first question is identify the relations which are symmetric but neither reflexive nor transitive. Only symmetric properties should be obeyed. Reflexive and transitive both should not be obeyed. So if we check that reflexive property should not be obeyed means we can't take R4 and R5. So check your R1, R2, R3 and make sure which of them are obeying symmetric property. R1 is obeying symmetric property because it has only two elements. 2, 3 is there. Its mirror 3, 2 is also there. So R1 can be considered. And check R2. 1, 2 is there but 2, 1 is not there. So symmetric property is not obeyed by R2. And R3 can be considered because 1, 2 and 2, 1 both are there. 1, 1 is self symmetric. So everything is considered. So symmetric property is satisfied by R3 also. So we have to tell this. Both R1 and R3 are symmetric. Why? Because A, B belong to R1, R3 both implied B, A also belong to R1 and R3. Therefore, both of them are symmetric. But reflexive property and transitive property are not obeyed by them. So that we have to tell there. Okay, reflexive property is not obeyed by R1. It's very clear because 1, 1, 2, 2, 3, 3, nothing is there in R1. So we can say reflexivity is not there in R1. Same way, transitive property also not there. Why? Because 2, 3, 3, 2 are there, but 2, 2 is missing there. So R1 is not obeying transitive property, that we have to mention. Also R2 is not satisfying reflexive property and symmetric property, as we see. 1, 3, 3, 2 is the only pair we can consider, but their combination will give you 1, 2. So transitivity is there. And R3 satisfies symmetric also, that we have checked already. And transitivity is not there because 2, 1, 1, 2 is there, but 2, 2 is not there. So we cannot say R3 is transitive. So let's see how we can conclude. So symmetric we have given explanation, but reflexive and transitive, why it is not obeyed, we have to give the reason there. So in R1, 2, 3 and 3, 2 belong to R1, but 2, 2 doesn't belong to R1. Therefore, R1 is not transitive. Also, 1, 1, 2, 2, 3, 3, none of them are available in R1. That implies R1 is not reflexive also. So we have given enough information, and let us write about R3 as well. In R3, 1, 1 is there, but 2, 2 and 3, 3 are not available in R3. Therefore, R3 is not reflexive. That is very clear. And why R3 is not transitive, we have to give the reason. Also, in R3, 2, 1, 1, 2 is in R3, but 2, 2 doesn't belong to R3. That implies R3 is not transitive. So our conclusion is R1 and R3 are symmetric, but neither reflexive nor transitive. Let's move on to the next subdivision. What pairs should be added to the relation R2 to make it an equivalence relation? Let us write our R2 relation given. So R2 is given to be 1 2, 1 3 and 3 2. We want to make it as an equivalence relation. So R2 should obey reflexive property, symmetric property and transitive property. As you can see, R2 satisfies transitive already, correct? Because 1 3 3 2 is the only pair we can take and it will give you 1 2. So no need to worry about transitive property, it's already obeying. But if you want to make R2 an equivalence relation, it should satisfy reflexive property. So 1 1 2 2 3 3 should be included here. So 1 1 2 2 3 3 should be included to make it reflexive. Okay, if you want R2 to be symmetric, 1 comma 2's image 2 comma 1 should be there. So we have to include that. And 1 comma 3's image 3 comma 1 should be included. And 3 comma 2's image 2 comma 3 should be included. And about transitive property, we need not worry much because only if you find A comma B and B comma C, the third pair should be there. We can find only 2 such pair. So its third pair is already there. So no need to worry about the rest of the things. We can confirm here also. If we take any 2, we have to get the third one. For example, if we take 3 comma 1 and 1 comma 2, it should give you 3 comma 2, it's already there. Same way, if you take 2 3 and 3 1, it should give you 2 1, that we have already included, so no worries. Same way, however you take any 2 pairs, the third one will be there automatically, it will be satisfied. So required pairs to be added to make the relation R2 as an equivalence relation are 1 1 2 2 3 3 2 1 3 1 and 2 3. So that's the end of this sum. Now let us move on to the third case study. Let's read the question. A bank offers loan to its customers on different types of interest, namely fixed rate, floating rate and variable rate. From the past data with the bank, it is known that a customer avails loan on fixed rate, floating rate or variable rate with probabilities 10%, 20% and 70% respectively. A customer after availing loan can pay the loan or default on loan repayment. The bank data suggests that the probability that a person defaults on loan after availing it at fixed rate, floating rate and variable rate is 5%, 3% and 1% respectively. Based on the above information, we have to answer the following. So this is probability based sum. So let us try to understand the sum quickly. So there are 3 different modes of taking the rate of interest, which is fixed rate. The name itself suggests you can't change the rate of interest any time after you take the loan until you finish your tenure. And floating rate means it will vary accordingly as the current rate. It may increase or decrease. Variable rate means you can adjust it according to your need by paying some amount and you can increase or decrease according to your requirement. So, a customer who avails the loan with fixed rate has a probability 10%, and a customer who avails a loan with floating rate is 20%, and with variable rate is 70%. And the person may default on the loan. That means the person fails to pay the loan completely. So, what is the probability for that? So, the person who availed the loan at fixed rate fails to pay the loan will have a probability of 5%. Same way, floating rate person fails to pay the loan will have a probability of 3%, and the person who took the variable rate fails to pay the loan is 1%. So the rate is very less. The chances are very less for the variable rate person failing to pay the amount fully. So now we need to answer the following questions. Question number 1. What is the probability that a customer after availing the loan will default on loan payment? Before solving this, we have to assign the events according to the given situation. So we have to assign, let E1 be the event that the customer avails loan on fixed rate, and E2 be the event that the customer avails the loan on floating rate. Same way, let E3 be the event that the customer avails the loan on variable rate. And their probabilities are already given by them. So, P of E1 equal to 10% is given, right? P of E1 equal to 10 by 100, which is 1 by 10. And P of E2 is given to be 20%, which is 20 by 100, which is 2 by 10 or 1 by 5. And P of E3 is equal to 70 by 100, which is 7 by 10. We can keep this like 2 by 10 only, because calculation will be easy if we take like that. And what else we know? Once you know that the person took fixed rate, the chances for the person being defaulting. Okay, so we have to assign another event. Let A be the event that the person defaults on the loan. So fails to pay the loan. Okay, so once you know that the fixed rate person is defaulting, the probability for that will be 5%, correct? 5 by 100, that's given in the sum already. And the person, if you know the person availed the loan on floating rate, the person failing to pay the loan back will be 3%, which is 3 by 100. And the person took variable rate, failing to pay the loan will be 1%, which is 1 by 100. So once we make all the events and their respective probabilities ready, it's easy to answer the questions. What is the probability that a customer availing loan will default on the loan payment? So we want to find out P of A. So the person may have taken fixed rate who failed it, and the person may have taken floating rate, may have failed it, and the person may have taken variable rate and failed it. So this is based on the multiplication theorem of probability. So we are going to do this by writing the formula, which is P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. We know their respective probabilities. Let's put them here. So P of E1 is 1 by 10 and A given E1 is 5 by 100 plus P of E2 is 2 by 10 and P of A given E2 is 3 by 100 plus P of E3 is 7 by 10 and P of A given E3 is 1 by 100. So the final answer for this will be 5 by 1000 plus 6 by 1000 plus 7 by 1000, and we can take 1000 as LCM and we can add the numerators. 11 plus 7, 18 divided by 1000. We can simplify this as also. That will be 9 divided by 500. So the probability that the customer after availing the loan defaults on the loan will be 9 by 500. Let's move on to the next sum. A customer after availing the loan defaults on loan payment. What is the probability that he availed the loan at a variable rate of interest? So this will be answered using Bayes theorem. This is the reverse probability, right? So once you know the person defaults on the loan, what would be the chance that he got the variable rate of interest? So we are going to do the reverse probability of the person paying the loan using variable rate as E3 event. So here we know that the person already defaulted. I mean A event has already happened. In that particular situation, what would be the chance that E3 to happen? So this will be applying Bayes theorem. This will be written like P of E3 into P of A given E3 divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. So P of E3 is 7 by 10 and A given E3 is 1 by 100, and the denominator's value is nothing but our P of A. We have already calculated this in the previous part. So this will be 7 by 1000 divided by P of A was 9 by 500, or we can take it like 18 by 1000 as well. 18 by 1000. So we can reciprocate and multiply 7 by 1000 into 1000 by 18. This will be 7 by 18. That's the end of this paper. Thank you. Hope this video was really helpful for your revision of concepts. Do share this video with your friends. Please stay tuned because we are going to solve many previous year papers together. Until we meet in the next video, happy learning.